Good morning, everyone, and welcome to the Kennedy Space Center, where we are preparing for the emergence of NASA's Space Launch System rocket and Orion spacecraft. It's going to be making a multi-hour, very slow crawl from the vehicle assembly building out to the launch pad, just out of frame on the other side of the camera. You're watching Spaceflight Now's live coverage of this historic milestone, the first crewed mission for the Artemis program for NASA. I'm Will Robinson-Smith, reporter with Spaceflight Now. It's very good to be with you here on a bit of a chilly, by Florida standards, Saturday morning, but a lot of excitement in the air here at KSC as we've got lots of family and workers here who have put in countless hours to get this rocket ready to roll out of the vehicle assembly building and down to the pad. And you can see over my shoulder right now we're looking at the back of both the crawler transporter as well as the mobile launcher. That's the large gray truss structure that's supporting the Space Launch System rocket and the Orion spacecraft on the other side. You can kind of see just a little bit peeking out on the left-hand side there, just a glimpse of the solid rocket boosters built by Northrop Grumman that will propel 75% of the thrust at liftoff for this 322-foot tall rocket on launch day. We're just a little bit past the top of the hour. It's 7:05 here locally here on the East Coast, and now is when NASA said that first motion was expected to begin. We haven't gotten an update from NASA just yet to confirm that first motion has happened, but Charlie Blackwell-Thompson, the Artemis launch director, did say it'll take about an hour for this vehicle to emerge fully from the vehicle assembly building and come out in the full sunlight here on the Space Coast. And of course, there's a lot of folks that are gathering and eagerly awaiting that moment to happen. So we'll bring you live views from multiple angles of the rollout of this SLS rocket as it makes its way from the VAB all the way out to Launch Complex 39B. Now, this is going to be a slow, methodical process. You remember, they've only rolled this rocket out from the VAB just a handful of times ahead of the first wet dress rehearsal campaign and the run-up to launch back in 2022, and they ended up having to roll the rocket back to the VAB the first time because they had some technical issues that they ran into during the wet dress rehearsal. If you remember, there were a couple of wet dress rehearsal campaigns before they really got into a rhythm with this rocket. And the second time that they had to roll it back was ahead of Hurricane Ian before it made its way across the Sunshine State and arrived here in Brevard County. They brought the rocket back into the barn here, made sure it was safe. But of course, we've learned that the SLS rocket can go through hurricane conditions because it was out at the pad when Hurricane Nicole came through back in November before launch day was upon us. And so this rocket is fairly tough. It can withstand a lot as far as wind, as far as rain, but want to make a couple of things clear to folks as far as the conditions for rollout. There are some constraints that NASA highlighted where they would not be able to roll to the pad. So just to highlight those pretty quickly, if the lightning forecast is greater than 10% within a 20 nautical mile range of the launch infrastructure, if there is a greater than 5% chance of hail in the launch area, if sustained winds in the forecast are greater than 40 knots and greater than 45 knots as well is something they're watching for, as well as if the temperature is less than 40 degrees Fahrenheit or exceeds 95 degrees Fahrenheit during the rollout event. Now, the only reason that they might have paused for a weather event here would have been because of the cold, but thankfully things have warmed up notably as the morning has gone on. And we do have confirmation now that rollout is in fact underway. It started about 3 minutes ago, so just about at the time that we started our commentary is when first motion occurred. So clock that at 7:05 when things literally and figuratively got into motion here at the Kennedy Space Center. And again, it'll take about an hour before this rocket fully emerges from the vehicle assembly building. So don't expect to see a lot of motion in the next hour or so, but we'll fill that time for you with our own emotion and talk about some of the things that are going to be happening once the rocket reaches the pad, as well as, you know, some of the processes that went into making today possible. We want to start with once the rocket leaves the VAB and makes its way to Launch Complex 39B, what they're going to be doing out there between now and launch day. And to answer that, here's part of our conversation, or the press conference actually yesterday, with Artemis launch director Charlie Blackwell-Thompson talking about those pre-wet dress rehearsal pad events.
We'll retract the crew access arm. That'll take a little bit of time, about 45 minutes or so. And then we'll pick up and we'll head out on our 4-mile journey to Launch Complex 39B. We'll be at a cruising speed of just under 1 mile per hour. It'll be a little slower around the turns and up the hill, and that journey will take us about 8 to 10 hours to get there. Once we get out to the pad, we'll begin and get hard down. We'll begin our connects to the facility, connecting our commodities, getting through our validations, getting connected back up to the firing room. We'll get prepared to power up the elements. We have some crew access arm swings that are going to happen out at the pad. When we first get out there, we've got emergency egress system to configure. We'll get ready for our pad testing, which is called pad PSET. It's a lot of our RF checkouts that we do. And we'll do our booster servicing, and we will get ready for wet dress. We do have a walk down with the crew called CDDT Part 2. It's a walk down of the emergency egress system once it's configured. We'll take care of that somewhere in and around our preps for wet dress is the plan right now based on the crew schedule.
Hey, Stephen. And again, that was Artemis launch director Charlie Blackwell-Thompson. Local time here, 7:12 a.m. Eastern, 12:12 UTC. First motion for the rocket was back at 7:05, so just about 7 or so minutes ago. If you take a look near the base of the mobile launcher, you can actually see some of the officials that are on the base of the ML on that first platform level. You can see them just in front of the bottom of the engine section in between the two solid rocket boosters. You see one of them in a red work shirt, see a couple of hard hats surrounding them. Of course, there's dozens of people that are both on the mobile launcher as well as that are going to be walking alongside the crawler transporter. In fact, the crawler transporter itself is a very interesting vehicle. It's was officially dubbed the largest self-propelling land-based vehicle by the Guinness Book of World Records, and it lives up to its name. It will be truly crawling at a blistering speed of less than 1 mile per hour. So don't expect this vehicle to be winning any road races, but it is critically important for moving this hardware and has been going back to the Apollo days. And if you look in front of the crawler transporter as well, you see the speed limit sign just down and to the right of that. That white truck is actually a water truck, and it has a very important job as well. It will be wetting the road for the crawlerway as the crawler transporter makes its way along the path to Launch Complex 39B. And that's important because they want to mitigate as much as possible dust and any other debris getting kicked up by the rocks and keep that tamped down Thankfully, the winds are light, so there's not a great risk of gusty conditions blowing things up into the crawler transporter, but it is a hardy vehicle. Nevertheless, having the dampened road is important to this process, and something that you'll see stopping and starting as the water truck moves along ahead of the crawler transporter to make sure that the roadway is safe for the vehicle to proceed. And in fact, for those of you who may be watching from Alabama, all of the rocks that are along the crawlerway come from Alabama rivers. So a little bit of a tie in here, in addition to, of course, the fact that Marshall Space Flight Center is nestled in the heart of the Rocket City. That's Huntsville, Alabama, for those uninitiated, sitting at the top of Alabama, just below the border with Tennessee. And that's where a lot of the engineering has been happening to create the Space Launch System rocket. Marshall is also the home of where the HLS, or the Human Landing System program, is based. And that, of course, is where officials are preparing the future Human Landing System vehicles. That is SpaceX's Starship rocket and Blue Origin's Blue Moon lunar lander. That's where it's being coordinated from on the NASA front. Obviously, Blue Origin has their own facilities here in Florida, and SpaceX has their setup down at Starbase, Texas. And actually, if you take a look at the rocket, if we can pan up a little bit, you can start to see some of the spotlight really hitting the solid rocket booster there to the left of the mobile launcher. The solids that are on either side of the SLS rocket are similar to those that were used back in the space shuttle era, but instead of having 4 segments of the solids, the SLS's solid rocket boosters use 5. But a lot of those do tie back into shuttle hardware, as do the 4 RS-25 engines that power the core stage of the Space Launch System rocket. Together, they've flown more than a dozen shuttle missions between them, with one that was built for the space shuttle program, but actually never flew, so it'll be making its debut on the Artemis II mission. Now, unlike the space shuttle flights, the RS-25 engines that support the Artemis program will not be recovered for reuse. So once NASA runs through its collection of RS-25 engines, it's actually moving to a next generation version of those, which will come into play on future Artemis missions. And as a matter of fact, Adam, if we can pan the camera to the right, I want to direct folks to another piece of critical Artemis hardware that's sitting out here. Going just beyond the C-3PF, you can see the future mobile launcher for Artemis mission, starting with Artemis 4. That is the Mobile Launcher 2, and it's needed because future versions of the SLS rocket are actually a good bit taller than the first 3 iterations of the rocket, the SLS Block 1 as it's known. The SLS Block 1B will use the mobile launcher that Adam has his camera trained on right now. And the reason for the difference in height is principally because the later versions, the SLS Block 1B, will use what's called the Exploration Upper Stage, which calls on 4 RL-10 engines to power that second stage of the rocket, as opposed to the rocket that we're going to see flying for Artemis 2 and again for Artemis 3, which its upper stage is called the Interim Cryogenic Propulsion Stage, or the ICPS, which just has 1 RL-10 engine powering it. As we're continuing to see the early emergence of the mobile launcher number 1, as well as its rocket Hitching a Ride, I want to thank the more than 1,300 of you who are watching along with us live. If you haven't already, you could do us a big favor just by clicking that like button and sharing the stream to allow some more folks to find their way into our live launch coverage. Also want to thank our wonderful channel member community who's here on YouTube, one of whom, Cumulus Granatus, is able to help answer folks' questions in the chat. Broader shout out, though, to folks like Super Tech Boy, Dave S. Shuttle, Space Coast rocket launches, Dagger, and many, many others. Joni, as a matter of fact, is marking 13 months with us as a channel member at the mission specialist level, saying, morning spaceflight now, Will and chat. Very exciting. and welcome back to Spaceflight Now's live coverage of the rollout of the SLS, or Space Launch System rocket, with the Orion spacecraft on top. 322 feet tall, moving at a blistering pace of less than 1 mile per hour once it hits the open road. First motion was back at 7:05, and as you can see, it is starting to emerge very slowly from the vehicle assembly building. It'll take about an hour to be fully out in the daylight. And we are fortunate to be joined by our first guest of the hour, Richard Trabue, who is the space reporter over at the Orlando Sentinel, also covering a whole myriad of things, including the cruise industry. Richard, always good to see you, my friend.
Thanks for having me. It's pretty nice out here. It's kind of nice to be in the daylight. As last time Artemis 1 was at night. But I will say I miss the big shadow once it emerges. That was the coolest thing 4 years ago.
4 years, yeah.
So.
Yeah, 2022. And here we are in 2026.
But this is exciting, and I think the crowds out here, I was trying to count them up. I'm definitely over 1,000. I'm not sure, but I know the lines to get onto base for the employees were building up after 5 a.m. So everyone seems to be pretty enthralled with this.
No doubt. And, you were in the room with us yesterday during the pre-rollout briefing. We heard from Charlie Blackwell-Thompson, who's, of course, the Artemis launch director, as well as one of the flight directors who's in charge of the mission after stage separation, and they get into the proximity operations. We heard a lot of things yesterday, but what was maybe one or two things that kind of jumped out at you about, that briefing in particular, where they're feeling right now as far as proximity to launch?
It's up in the air as to whether or not they'll actually be hit this February window. I mean, everyone seems to be like like they want to do it, but my feeling is that everything would have to fall into place, and it's more likely that we'll probably spill over to March or April. I know that some people are even betting farther than that, but I liked Charlie's response to the questions. She said, we'll let the wet dress tell us what we need to do. And I know as reporters, we love to just, when? And NASA, God bless them, they have to answer the question over and over and over again. So I guess we should give them a chance to actually see what they've got their hands on before we actually get the date.
Yeah, I think part of the anxiousness from that is, we're sort of the emissaries to the public, and the public is trying to determine, when should I buy, if they're coming from out of town, when do I need to buy a room here? Can I buy a ticket to watch it at some of the special launch sites from the visitor complex? And, a lot of those can't really be answered without a firm launch date. So it's sort of a, maybe get a room now and find one that has good cancellation options, but that's about as good as we can give you.
Yeah, and in the meantime, you might accidentally catch a SpaceX launch. So, it's not too bad if you come down for one and you get the smaller cousin instead. So, I have a son, and he was trying to figure out when to come out here and maybe catch it. He's actually coming tomorrow, so should be a SpaceX launch tomorrow to enjoy, and maybe he'll get to see this thing on the launch pad from afar.
And, in the days and weeks to come, as we, see NASA go through these pre-launch checkouts leading up to wet dress, what are you most closely watching for and waiting to see the outcome from to kind of, get a good bearing in your mind of where we are realistically?
I'm really interested to find out what the 4 astronauts have to say after they get a walkthrough of the thing on the pad. I mean, they're not the experts, but I kind of want to know them. They're somewhere in between a layman and an expert. And once they get out there, especially Victor, because Victor will not lie to you. He's
a straight shooter.
He is, and he'll tell you first that it's his wife and kids who tell him what he needs to be making decisions for in terms of safety. So, and his dog. But so I'm kind of curious to see what their feelings are, and looking forward to talking with them later today, in fact. So.
Yeah, and for those unaware, it's currently just about at the bottom of the hour right now, and in about 9 o'clock is when we are expecting a briefing over by the historic countdown clock with Administrator Jared Isaacman, as well as the 4 members of the Artemis 2 crew. So we'll be able to hear them in their own words as this rocket is slowly making its way out to the pad. So certainly going to be an exciting part of this morning.
Yeah, I think that's a nice highlight, and they're gonna have their ride to space, and I'm really jazzed about the fact that these guys are going to be record setters. 600,000 mile trip, 4 miles from here to the pad, another 600,000 miles to go, and really hoping that this actually pulls through, that it's not just a flight up to Earth and around and back, that they can actually make the moonshot. And they're starting to get excited, and I'm supposed to be objective, but I am too.
Oh, of course. And, just as an example of how early it is, my watch is telling me to wake up right now. So apologies, going to disable that alarm. It has been an early start to the morning for us here. But of course, we wanted to bring you the very best and the very latest of this rollout. So just to wrap up, Rick, we saw this rollout in daylight once ahead of Artemis 1. It rolled out again in the middle of the night before the launch itself. Kind of nice that we get a daylight rollout. I mean, I know it's because it was going to be really cold tonight, but, it's kind of a nice silver lining.
That's true, and it's quite comfortable out here today, and I'm actually overdressed all of a sudden. So
it's a nice surprise.
Thank you, Florida. But yeah, I'm very keen to see this thing actually get away from the building and out in the open air, and see what everybody's excitement brewing up turns into be. It's a pretty cool feeling.
And we've got, just looking on the other side of the camera, some breaks in the clouds. So hopefully once the sun gets high enough, we'll get some streaks of daylight on this rocket, and that'll be a nice little pop of color. Richard Trabue with the Orlando Sentinel, thank you so much for joining us this morning.
Thank you for having me.
And of course, we'll have much more, including that upcoming briefing from the crew and Administrator Isaacman for you at 9 o'clock. So be sure to set your own alarm for that. But we've got continuous coverage throughout the rollout. You're watching Spaceflight Now here, the rollout of the SLS for Artemis 2. And we're just about 3/4 of the way through the 7 o'clock hour, 7:44 here local time. You're watching Spaceflight Now's live coverage of the rollout of the Space Launch System rocket and Orion spacecraft. It has largely emerged from the vehicle assembly building. If you see the side shot here, John, if we're able to switch to the side shot showing the rocket outside of the VAB. You can see it has fully come out. One of the steps that they're going to do once it is at its pause point is they're going to retract the crew access arm, which is, of course, still out at the crew module of the Orion spacecraft. Crew module sits on top of the European service module, which brings in the important things like the propulsion system for Orion, as well as the water and other components of the ecosystem that tie into the crew module. That's one of the things that will be tested robustly in the first day after liftoff, is all the various life support systems that weren't in play last time, since of course there were no humans on board the Orion spacecraft. There was the mannequin, lovingly called Moonican Campos, as well as a couple of radiation torsos from the German aerospace agency DLR that were outfitted, one with radiation protection vest, the other just bare in the cabin. And that's in part, which they'll also be testing here, to learn more about the radiation environment and some of the shielding areas in the Orion spacecraft, to gather more data about how astronauts will be potentially impacted as crews go deeper and deeper into space. Of course, first to the moon and then eventually onto Mars and beyond. In the lead up to the rollout, we were told by Artemis launch director Charlie Blackwell-Thompson that it would take about an hour for the vehicle to fully emerge and for them to do the work that they need before the crawler transporter really starts to get into motion and make its way down the crawlerway. And it'll be passing our position here just a little bit down the road in the hours to come. As a reminder, there's also going to be a briefing with NASA Administrator Jared Isaacman, as well as the 4 members of the Artemis II crew: Reid Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen. That's coming up at 9 a.m. Eastern. That's 1400 UTC for our friends watching from around the world. Once the rocket gets out to the pad, there are a number of operations that need to happen before they get into the flow of the wet dress rehearsal. Those include, of course, getting all of the various connection points synced up with the mobile launcher and the pad infrastructure, and doing some checkouts in the RF or radio frequency environment that they'll experience at the pad, making sure that all the systems are tied back into the building that is in this frame just to the bottom left of the rocket. You see that sort of white building with the row of windows. That is the Launch Control Center, or the LCC. And they want to make sure that all the systems on Orion and the SLS rocket and the mobile launcher are all in sync in firing room 1, where the mission launch will be controlled. As we're rolling through the morning, I want to thank the more than 1,400 of you who are up early with us to watch this historic rollout live. If you haven't already, you could do us a big favor just by clicking that like button and sharing the stream to allow some more folks to find their way into this live launch coverage. As far as some of more detail on the work, that will be happening out at the pad. Call an audible here, Stephen. If you can ready video 3, we'll go ahead and hear Charlie Blackwell Thompson talk about what's going to be happening out at the pad once they are in operation after the hard stop and they're down at Launch Complex 39B. Stand by, we're just getting that video primed up and ready for you. In the meantime, of course, we'll also be watching for incoming super chats and comments from our channel members here on YouTube. If you have comments or questions about the rollout operation that we can hopefully try to answer for you, or about other goings-on with the Artemis program and the run-up to launch. Certainly want to welcome in a few new channel members that we've had join us this morning. Welcome into Noel Gantley, to user M9N8C, Air Twiga, and My Honey, all joining us with channel membership at the pad leader level. Also thanks to Super Tech Boy for a $2 super chat, saying, jokingly I think, for Lego, didn't see an Artemis set on Will's shelf. You know, personally, I'm hoping that they come out with a 1/100th scale that would match the SLS, or match the Saturn V rocket model that Lego put out some number of years ago. That's just my own personal hope for that. But of course, we are in no way connected to or sponsored by Lego, so have no sway or impact in that regard. Question about when Artemis 3 is planned. Currently, that is, depending on who you ask, generally speaking, slated for mid-2027, though the mandate from the administrator and from the president is to have Artemis 3 fly before the end of 2028. So that will depend, of course, on a number of things being ready. Of course, the assembly of the next Space Launch System rocket and stacked with the Orion spacecraft, which pieces of that are already actually here at the Kennedy Space Center. Part of the engine section is in the VAB as we speak. But they also need the human landing system, which currently SpaceX is on contract to provide, that HLS lander. And they also need the suits for the EVA activities on the lunar surface. Those are coming from Axiom Space. So those are both not to be discounted as very important pieces of the puzzle in order to make the Artemis 3 launch come to fruition as currently architected. Oh, good question. Got a comment here from Patriot Pepper Company saying, I remember visiting KSC 50 years ago and seeing America's bicentennial logo on the VAB. Good grief, where's the time gone? And yes, once the SLS rocket does pass us here, you'll be able to see the America 250 logos that have been painted on both of the solid rocket boosters. It's not visible from our side, but of course it matters the most that it's on the other side, since that will be what's visible most prominently at liftoff. In this vantage point, actually, you can see the Artemis program logo that was added to the outside of the white room adjacent to the crew module. of the Orion spacecraft at the top of the stack. Just above the white room, that is the launch abort system, or the LAS. In the event that there were an issue with the rocket as it is in the last 5 minutes of fueling, or as it's making its ascent before the LAS is jettisoned, it's able to use those 4 motors at the top to very quickly and speedily get the crew away from the rocket. And as things are continuing to be fluid, there was an announcement just a moment or two ago for folks that are on those upper levels of the mobile launcher to clear the area as they're preparing to retract the crew access arm. So what we're going to see visually is the arm swing away from the crew module portion of the Orion spacecraft, and it will tuck in flush to the mobile launcher itself. And that'll be the configuration that we'll see the full stack start to roll in. So this is one of the last big parts that needs to happen before movement down the crawlerway is able to get underway. Moving on down the Artemis stack from this vantage point, of course, we mentioned the LAS and the crew module. Just beneath that, where you see the NASA meatball logo and the ESA logo, the European Space Agency, that is the European Service Module, again, providing things like power, propulsion, water, and other life support systems to the overall Orion spacecraft. Just beneath that is the Orion stage adapter. You can see that with the from this vantage point, you see those 2 black squares that are diagonal from one another. That is the Orion stage adapter. And after Orion separates from the upper stage, the interim cryogenic propulsion stage, there are 4 CubeSats from various countries around the world. Those will be released from that stage adapter only after the proximity demonstration is conducted. And that'll happen in the hours following liftoff and, of course, stage separation. Just beneath that is the launch vehicle stage adapter. That's the sort of conical-shaped bit of the core stage. So right underneath where you see the American flag, that cone shape is the launch vehicle stage adapter. And then you get down into the heart of the core stage itself. Space Launch System rocket provides more than 8 million pounds of thrust at liftoff, and the majority of that comes from the 2 solid rocket boosters that are produced by Northrop Grumman on either side of the core stage. Time now just past the top of the hour, 8:01 here locally. You're watching as the crew access arm is in motion, retracting away from the crew module of the Orion spacecraft. This arm will be stowed as part of the pre-roll movement, and this was one of the last big pieces before we see the crawler transporter really get back into gear to take this SLS rocket and Orion spacecraft the 4 miles it has, which hopefully, if all goes well, will be its final road trip before it's ready to take crews for the furthest distance that they've been from Earth in history. And certainly the closest we've been to the moon since 1972 and Apollo 17. So we're going to stay with these live pictures as the arm continues to retract away. There are some people that are on the level of the crew access arm who are watching this operation happen up close to make sure it goes to plan. And they'll actually do a couple of arm swing tests once the rocket gets out to Launch Complex 39A as part of their pad flow operations before the crew arrives to do a walk down at the pad and see the launch vehicle where they will be flying from. They've already done a similar type of walkthrough, but the last time they did that, there, of course, wasn't a rocket there. The mobile launcher was out there, so they were able to go through a lot of the launch day motions up to the point, of course, where they had to stop since there wasn't an Orion spacecraft for them to get into. But that was part of the CDDT Part 1, the countdown demonstration test inside the vehicle assembly building, where they got to go through the full motions of launch day down to about 29 seconds ahead of the simulated liftoff. As we're continuing to watch these pictures here of the crew access arm retract, you're going to hear a secondary voice, and once the arm is fully retracted, we'll bring him in box in box. But we're joined now by Mr. Paul Benfield, the Orion Artemis II spacecraft manager from Lockheed Martin. It's good to see you this morning. Thanks for being with us.
Great to be here. Thank you so much.
And of course, we've got a lot of activity behind us with the crew access arm that is retracting from really your baby, the Orion spacecraft. We've seen Orion launch once before, of course, and had a lot of great milestones that it passed. But what's it like in your position, seeing it now emerge from the VAB for the first time ahead of this crewed flight?
Yeah, this is a huge moment. We've talked about this is really the start of the Artemis II mission now. This is the start of the journey out to the pad, eventually on the mission. And this is a day that's been long coming. It's very exciting for the whole crew and the workforce to be here today.
And of course, as I mentioned with the countdown demonstration test, that was, a good opportunity for the crew to get inside Orion, for all the teams to be tied in. Walk us through from your vantage point, what was CDDT like, getting into that flow, coming out of it? What were some of the lessons learned, having everyone tied in?
Yeah, CDDT was very important. The launch cadence isn't what it used to be in shuttle, where the teams were used to a more regular flight cadence. So that practice, that exercising the procedures, going through that process. We've got a lot of colleagues and friends that work the different console supports, and this training is really valuable to them, to the crew. Fortunately, we didn't have a lot of learning events from CDDT from an unexpected standpoint. The hatches worked well. That was a big focus for us to ensure that the last hatch and the crew module hatch were going to function as expected. That all performed very well. So overall, we're working some small lessons learned, some cabin refinements from CDDT, but overall, it was a very successful test and very important.
And getting into CDDT, there was a hatch closure test that shuffled things around schedule-wise, but it sounds like you were able to get through the blemish issue, right, and then proceed into that countdown test?
It has, yeah. We've had a few late realizations of improvements we wanted to make on the last hatch side. We were able to get all that implemented before CDDT, and so that test where they did the full opening with both hatches worked just as expected. So we think we're essentially done with all that, and we're ready for flight with the hatches.
And, in the first day or so after, liftoff, separation, and the crew really get to shake out Orion and its systems, What kind of feedback are you wanting to hear from the crew once they're in orbit and able to really get a sense of how the ecosystem works and, put their hands on the controls for the first time?
Yeah, it's exactly that. You touched on it. So for us, the Eclipse performance in that first day and a half is going to be of great interest to us, all the systems. But as you've touched on, the life support systems, this is first flight for those, and the crew will be shaking that down. They'll be shaking down the hygiene bay, all those different things, and be an important first day and a half of the mission to ensure that we're ready to commit to going to the moon.
And, obviously you want to see the crew go to the moon. They want to go to the moon. But they've, been upfront with the fact that, things need to work before they're ready to commit with the TLI burn. If there were to be an Orion-based showstopper in your mind, what are some of the things that you want to make sure, really pass the muster before that all-important burn that sets the course for everything else?
Yeah, we work closely with the Flight Ops Directorate and all the flight rules and all the criteria that goes into exactly that, committing to the TLI burn. So it's across the board, from prop systems to life support, mechanisms, solar arrays, power systems, all that's going to get full checkout. All the criteria has been scrubbed, thought about. That's what we love about our FOD partners. They're always thinking ahead, 2 and 3 failures ahead. And the teams are training for that. That's why the simulations are so important. As you know, exercising that criteria, really challenging, finding gray areas in that. So as much as possible, that's been thought ahead. All the systems will get a full scrub, and the teams are going to be very busy, as we've mentioned, that first day and a half, making sure everything looks good. If there are anomalies, then that'll go through the right review boards, and the teams will make the right decision whether we're okay and ready to commit to that TLI burn.
And from an Orion perspective, once the rocket is down and configured at the pad here, what are the main things that need to be checked off the list in your mind, before the crew's ready for a walk down, before you get into the wet dress?
From the Orion standpoint, we don't have a lot of tests that we need to see results at the pad, so we'll go through a full power up, and for us it'll be a normal checkout, but there's no other tests where we're looking for specific results other than systems performing well and as expected. We'll take a few consumables samples. We're going to check the water system one more time, make sure everything looks good there. But overall, our checks on the Orion system are done. We're ready to go. We'll be confirming that everything still looks good at the pad.
And of course, one of the storylines about Orion from Artemis 1 that has received a lot of attention and a lot of validation, to be fair, from the crew and from other mission managers, has been the heat shield. The last time the Artemis 2 crew was here and they had a news gaggle, they went one by one saying, why they had confidence in the heat shield and the assessment evaluations that have been done. In your mind, when you look back at the saga of, the Orion from Artemis 1 coming in and the evaluations that were done after that, what's kind of your takeaway from that whole process?
My takeaway from that process, I came in kind of late into that root cause investigation, but I've had the opportunity to work with the teams on the corrective actions and how we're mitigating that going forward. And the rigor that's been performed in the testing and the analysis has driven to root cause. We've shown we understand the physics of what's happening. We've identified how we can control that on this mission, and we've identified how we can improve it going forward. So we're doing both those things. We've put the controls in place to ensure that we're going to get the performance that we expect on this mission. And then starting with Artemis 3, we went through a process to rebuild that heat shield and get the full capability back. So from both standpoints, the data supports that we've got a good heat shield, working closely with the engineering teams and the technical teams and being able to look them in the eyeball and hear their reports and see the rigor in that whole process. Independent review teams coming in, validating that work. It's been a really thorough exercise getting ready for this mission as well as Artemis 3 and beyond, and so there's a lot of confidence in that position going forward.
And obviously Artemis 3, that Orion spacecraft is going to be coming back from near rectilinear halo orbits, so a different trajectory. I've heard it described almost closer to Artemis 1 than Artemis 2, since this is a free return. How are you kind of thinking about that return and the energy that needs to be taken out coming from that type of trajectory versus what we're seeing on Artemis 2?
Yeah, we've been built for that type of return all along, so we will see a different type of entry, and that's where we'll be willing to take advantage of the extended downrange and the skip reentry capabilities. And what that'll allow us to do on Artemis 3 as well is open up the launch availability windows and have more flexibility and more opportunity in that as well. So I think we've been designed for that all along. Artemis 3 will be our first capability to get back and exercise that full range.
And of course, we just heard from ESA that they've delivered, I believe, the European service module for the Artemis 4 flight.
Yes.
Can you talk about where the crew module is in flow for Artemis 3?
So Artemis 3, yeah, I'm glad you asked that. Some of the folks that we have down here that are getting a chance to see the vehicle are here because we're testing the Artemis 3 vehicle as we speak. We have it over in thermal testing right now and shaking out those subsystems. So that vehicle's progressing well. In that production area, we've got vehicles 3, 4, and 5 all in work right now. So 3 is pressing hard. We want to get ready for that next crewed mission and be ready as soon as possible so that we can get back to the moon on that flight and get down to the surface.
And obviously there's, a number of things that have to tie in together to make Artemis 3's schedule work. But from an Orion perspective, where would you say you are maybe percentage-wise between, today and how close, your part of this puzzle is to saying, we're ready to launch when everybody else is ready to tie in?
Yeah, sure. So you're asking schedule overall, essentially. We're pressing hard with NASA to make, I think the latest numbers that NASA's put out is no earlier than 2027, right? And we're pressing hard on that every day. We look for opportunities in the schedule. We're always learning from each build. We learned a lot from Artemis 1 to Artemis 2. We're translating that over Artemis 2 to Artemis 3, looking for are there opportunities to take some accepted risk and lean forward? Maybe there's some testing that we can accelerate, those type of opportunities. We're not going to cut corners, but we're going to look for the right risk opportunities where we can accelerate schedule, maybe accelerate some hardware, combine some different testings that had been done separately. We can find opportunities. We're always looking for that. The ATLO team that builds and tests this vehicle, we've learned if we give them a challenge and we give them the right hardware, they can perform just about any task and usually do it faster than we expected. So we don't think Orion's going to be a constraint on the schedule for that next flight, and everything's lined up well for that.
Last question. We're potentially just a couple weeks away from Artemis 2 launching, a really important test for Orion. What's maybe in your mind, the most stressful point when you see Orion get past that? You can sort of, breathe a little bit easier, getting to that point in the mission.
Absolutely. That's a great question. And, we have some risk profiles that show how the risk gets retired over the course of the mission. And so definitely that first hour and a half or so, just getting to orbit, getting solar arrays out, getting the vehicle up and functioning, we retire a major amount of the risk through that period. So there's going to be a lot of excitement and a lot of good feeling much better once we get through that portion of the mission. And then knowing that we need to perform, eyes then start to go on getting the crew back home. So we'll have a nice 8 days or so outbound to the moon, observing the moon and getting back, and then the focus will be on that entry phase where we realize a lot of the additional potential risk there. So it's kind of maybe front end and back end loaded on this mission.
Super last question, just because I was thinking about the back end. When Orion is safely tucked in, has been brought to shore, when do you get Orion back and get a chance to really evaluate how your vehicle's looking post mission?
Right. I don't have the exact numbers for you. I'd have to look that up, but we have learned from Artemis 1 that the quicker we get that vehicle on board the ship, we get things into the cleaning process, as well as getting it back to KSC as quickly as possible so that we can do the thorough cleaning. It's really going to help improve the turnaround time on the equipment and help minimize the corrosive effects that we see. We saw, I believe, a little bit more than we expected on Artemis 1, a little bit deeper than we expected, so we're going to take more measures on Artemis 2 to get cleaned up more thoroughly, quicker. We have 300 plus components that we want to pull out of Artemis 2 and move forward on the Artemis 5 vehicle, so it's important to us to get that vehicle back, get it cleaned up, and minimize that type of corrosion. And then that's also informed us on the Artemis 3 build, where we can add some additional protective measures to help minimize water intrusion and other corrosion that's going to help improve that going forward also.
Saltwater's a nasty business.
It's terrible, yeah.
Well, Paul, thank you so much for taking the time to talk with us. It's been insightful, and I'm sure our audience really appreciated it.
Thank you so much, yeah. Go Artemis 2.
Artemis 2, and of course you can see the crew access arm looks like it is just about fully retracted. We've got a lot more for you on the rollout coming up here. We're about quarter past the hour, and in about 45 minutes we'll be hearing from Administrator Reid Wiseman and the crew themselves of Artemis 2. You're watching Spaceflight Now's live coverage of SLS and Orion rollout. Time now, bottom of the hour here, 8:31 on the East Coast. You're continuing to watch Spaceflight Now's live coverage of the rollout of NASA's Space Launch System rocket and Orion spacecraft. The crew access arm has now fully retracted. We've seen the engines of the crawler transporter seem to spring to life a little bit more. You can see some of that diesel exhaust for that massive vehicle. So it seems like crews are getting ready to get into motion with the crawler transporter, and this rocket will be more vividly on the move. Again, it moves at a blistering pace of less than 1 mile per hour, so it's a very slow process of getting it from the vehicle assembly building out to the pad at Launch Complex 39B. But in 30 minutes, we are expecting to hear from NASA Administrator Jared Isaacman, as well as the full crew of Artemis 2, Victor Glover, Reid Wiseman, Christina Koch, and Jeremy Hansen. That'll happen at the top of the hour as scheduled, 9 o'clock. So we're going to go ahead and relocate. We're not relocating entirely, but take some of our capacity, and I'll be heading over there to hopefully be able to ask a question to them in, again, about 30 minutes or so. And we'll bring you their full comments once they do start. So just want to make folks aware of that we'll be in transit, and you won't hear commentary from me for just a little bit. You might hear my colleague Stephen Young on the mic as we're making our moves. You can see the water truck is now spraying down part of the crawlerway ahead, as we mentioned earlier in the broadcast. But for those who were not here, this water is designed to dampen the road, to reduce the amount of dust and debris that might get kicked up by the crawler transporter as it moves out away from the vehicle assembly building. Again, it's about a 4-mile trek from the VAB to Launch Complex 39B, and we'll be with you through the process here. Again, pausing on commentary from me, but not pausing on the live views, so don't go anywhere. You're watching Spaceflight Now's live coverage of the rollout of the Space Launch System rocket and Orion spacecraft. Comments from the administrator and the crew coming up in less than 30 minutes.
the launch pad. Good morning, and thank you for coming out here today to witness this monumental step ahead of our return to the moon. This morning, as that happens, I am joined here by the Artemis II crew, NASA astronauts Commander Reid Wiseman, pilot Victor Glover, and mission specialist Christina Koch, and CSA astronaut mission specialist Jeremy Hansen, as well as NASA Administrator Jeremy Hansen. With that, NASA Administrator Jeremy Hansen.
Thank you. Good morning, everyone. Thank you for coming out to witness this historic moment. Before I turn it over to the real stars of the show here, the Artemis II crew, I thought I'd take a moment to just share a little bit about the journey that we're on right now and President Trump's vision for American leadership in space. Now, this all began, call it just about 9 years ago. President Trump established the Artemis program, committed America to returning to the moon. Now, none of this should be a surprise. This is the president who created the Space Force. This is also the president that oversaw, during the last year of his term, the return of American spaceflight capability here to Kennedy Space Center after nearly 10 years from when the shuttle was retired. Now, I can tell you we're off to a little bit of a slow start here. We've got about 12 hours to go, approximately, before the Artemis II vehicle will make its way over to launch pad 39B. Now, from there, things will start to pick up the pace a little bit. So we'll have technicians put it through its motions. We'll ultimately get to wet dress. And then from there, this vehicle, along with about 8.8 million pounds of thrust, is going to accelerate the Artemis II crew here to near Earth escape velocities, so just under 25,000 miles per hour, farther into space than we've ever sent humans before, around the moon, back here safely to Earth. Now, this is the start of a very long journey. Now, we ended our last human exploration of the moon at Apollo 17, the 17th mission. Now, I hope someday my kids are going to be watching, maybe decades into the future, the Artemis 100 mission. Now, we're talking about a lot of repeated missions, humans and crew members and cargo going to and from the lunar environment. Now, the architecture you see behind us here with SLS and the Orion spacecraft is just the beginning. Now, over time, launching missions like this, we are going to learn a lot. And the vehicle architecture will change. And as it changes, we should be able to undertake repeatable, affordable missions to and from the moon. And in that same vein, just as we begin, the cost to undertake a mission like we're going to undertake with Artemis II is not inexpensive. But where it'll go as we learn and gradually incorporate reusability is what's going to enable missions like Artemis 100 and beyond, right? And why are we doing this? We are doing this to fulfill a promise to the American people that we will return to the moon, a promise to all of the pioneers, the engineers, the scientists, the astronauts, the researchers from the 1960s, of which laid the foundation that we are standing upon right now. We'll do it inevitably to figure out the orbital and lunar economy, for all of the science and discovery possibilities that are out there, to inspire my kids, your kids, kids all around the world to want to grow up and contribute to this unbelievable endeavor that we're on right now. And before I hand it over to Commander Wiseman on this, I just want to acknowledge the contributions from literally the army that we have at NASA that shows up to work every single day to try and change the world. We don't do it alone. We have commercial partners, we have international partners that are involved in this, but we have thousands of people that have brought us to this moment. The thousands of people that have been working near 24/7 preparing us for this rollout, the thousands of people across the country that trained and prepared this crew to undertake this mission, the controllers that'll look out for them on space, the recovery crews that'll bring them safely home to their family at the conclusion of their 10-day journey. So with that, ladies and gentlemen, this is your NASA. Commander.
Thanks, Jared. Appreciate that. You said we're off to a slow start, but I heard Ike's going to go over there after this and drive, so we'll pick it up. The relative motion looks good, though. What a great day to be here. On behalf of myself, Victor, Christina, Jeremy, Administrator Eisenman, thanks for having us out here. And this is a great way to start rollout morning at Kennedy Space Center. I just want to build on what you just said about these teams. We see this beautiful hardware behind us, the SLS, the Orion, but for this crew, we've been on this journey for about 2.5 years, and we truly look at that and see teamwork. We see global cooperation. We see a strong nation leading the way. You look at those white boosters on the side. We've been out in Utah. We've met the men and women that are assembling them, that put them on rail cars and send them down here to the Cape. The core stage in the center, built by Boeing. Jeremy and I were there at Michoud when that thing got loaded on the barge and shipped down here with the RS-25s, tested at Stennis, assembled to the bottom of that rocket. The interim cryogenic propulsion stage, we met that whole flight control team out in Denver with United Launch Alliance. Building up into the European service module, we were in Bremen, Germany, meeting the Airbus team that has assembled that, and the European Space Agency, and then up to our Lockheed Orion. We spent so many countless hours in that vehicle preparing. And then you look just to the left here at launch control, it's almost eclipsed, well, it is eclipsed by the VAB. Charlie Blackwell-Thompson leading her team and the exploration ground systems folks, that they have hit every single milestone for the last year to get to where we are today. They've hit every single one of them. It is awe-inspiring. And then back in Houston with our flight control team, led by Jeff Radigan and our launch directors, we really are ready to go. We were in a sim for about 10 hours yesterday, doing our basically final capstone entry and landing sim. We got in T-38s last night, and we flew here to the Cape to be here for this monumentous occasion. With that, I just really want to say thank you to all the press that are out here getting our message out. It's very important. And hand it back to Bethany. Thank you.
And with that, we will open the floor to questions. There is a mic over here on the left, and we ask that you limit to one question each so that we can get to as many people and questions as possible.
Hi, Marcia Dunn, Associated Press for Mr. Isaacman. What's your take on how realistic it is that Artemis 2 will take off in February? And if I might really ask Reid a real quick question, I loved your crescent moon shot recently. What's it like to go outside at night and look at the moon now?
So, I guess take the first part of the question. I mean, we're continuing on with our Artemis 2 preparation campaign. I think we've held schedule pretty well, getting to roll out today. So we'll get out there. We'll put it through its motions. We'll get through wet dress. We have, I think, zero intention of communicating an actual launch date until we get through wet dress. But look, I mean, that's our first window, and if everything is tracking accordingly, I know the teams are prepared. I know this crew is prepared. We'll take it.
We like that answer. Going out and looking at the moon at night, I'll hand this all down the line. I'll be brief, but I think one of the most magical things for me in this experience is when I looked out a few mornings ago, there was a beautiful crescent in the morning sunrise, and I truly just see the far side. So it was a waning crescent here, so it's a waxing gibbous on the far side, and you just think about all the landmarks we've been studying on that far side and how amazing that will look, and seeing Earthrise, those sorts of things, just flipping the moon over and seeing it from the other perspective is what I think when I look out right now. Like,
yeah, thank you for that question. It is definitely different now, but it's also kind of like asking a kid how they feel about their homework. You know, it's a part of what we've been studying and training for, and I go outside and now I think of it in a very different sense, that there's some scientific value in what we say about what we see. And we had a sim months back where when we walked out in the parking lot, Christina and I were standing there, and it just had this overwhelming feeling that, like, wow, what science about the moon does in the future is going to at least be affected a little bit by what we say about that view. And so that has changed how I look at the moon since. And my dad asked me when we got a sign, do I see it differently? And I didn't right away, but I definitely do now because of the great team that we have getting us ready to do science. Nana?
I think for me, what I see is the fact that all the people here on Earth, when they look up at the moon during our mission, before our mission, after our mission, during Artemis 3 and missions beyond, all the way to Artemis 100, they'll know that not only have we been there in the past, but we actively go there. We send people there because we're humans that must explore.
Something I'll share with you. It was kind of neat. Over the New Year's time period, had a little time off, had my kids back at home from university, and we just had the best viewing weather in Houston for the moon, and it was approaching a full moon, and I had the kids out there, some mandatory science, observing the moon with me, teaching them landmarks that we've been memorizing as a crew, but they were lit up about it too, and that was just really fun. And I think the moon is something I've sort of taken for granted. I've looked at it my whole life, but then you just kind of glance at it, glance away. But now I've been staring at it a lot more, and I think others are going to join us in staring at the moon a lot more as there are humans flying around the far side. I think that's just good for humanity.
And with that, we'll take the next question.
Hi, thank you so much. TJ Mascaro with the Epoch Times. This question is for Victor and Jared. Looking ahead to missions like Artemis 100 and just the future of our space activities, a lot of talk seems to be around automation and computer pilots and all of that. I was wondering how important it is that we continue to build on manual flying in space, and what place will that have going forward?
It's interesting. First of all, did you target me because I'm a little bit of a Luddite, and I love, the inceptors or the controls that I can, put my hands on if I'm going to fly something. But I think what the last 5 years has taught me since flying the SpaceX Dragon, the same one that Jared flew, is that the tool needs to be designed for the task. And so I could, go on and on about this, but I think it is something that we have to think more about because the state of technology is where it is, and we're not going to undo all of that. And so finding ways to integrate software, hardware, but the thing that hasn't changed, as far back as we can read the record, we are still the same stuff. And I've been reading these, there's a journal that test pilots put together, and the Mercury and Gemini and Apollo astronauts used to go and give these presentations. And I've been reading their reports, and they say the same things that we say, that, having a window is important. Having the ability to do critical functions is important. And just how we implement that, though, is going to change with the state of technology. Thank you for the question.
We're just talking about an evolution in terms of what what are truly the manual inputs, right? So I would say probably the T-38s you're flying are maybe some of the last aircraft you've touched that actually, when you put a control input in, you're actually directly moving a flight control surface. A lot of the 4th and 5th generation aircraft that are flown today, it's all fly-by-wire. So you're telling the airplane what you'd like to do, and then the computer's interpreting it and saying, this is what I'll give you. And I think you're going to just naturally see that evolution in spacecraft, right? We're not taking the human out of the loop, right? There can be some pre-planned waypoints as we navigate around the moon, and then perhaps a human is directly inputting this is the actual target location I would like to land at for some reason. The computer's taking that manual input and saying, now I'll put you there, right? And I think that's probably the evolution we're looking at. But no doubt, look, as we get farther into deep space exploration, the ability to rely on autonomous capabilities within the spacecraft become more and more important. And I'd say the moon is going to be a perfect proving ground for that, right? So we talk about building a moon base. Now, day one of the moon base is not going to look like this, glass enclosed dome city that we might imagine someday. That's certainly what the ideal end state would be, but it's probably a lot of rovers that are moving around, a lot of autonomous rovers that are experimenting with mining or some mineral extraction capabilities to start, printing with regoliths. So naturally, I think in terms of what we want to achieve in space, you're going to incorporate more autonomy in our robotic missions. We're looking at a mission to Venus right now that could have some onboard AI capabilities in it. So this is the way we're going to go. But I'll tell you, if humans are on a spacecraft, they'll always have a vote. They'll always have a say in it. How that may look today could be very much like the F-22 versus the T-38 of the past, if that makes sense.
And with that, we will take the next question.
Hi, thanks for doing this. I'm Ken Kramer, Space Up Close. Good luck and best wishes to Crew 11. I'm a pharmaceutical researcher, so I want to ask you about the science you're going to be doing. Tell us a little bit, one or all of you, how it's going to benefit Earth and also how it's going to benefit us getting to Mars. Thank you.
Go ahead.
I think that's a great question. One of the reasons that these missions are so important is the discovery and the knowledge that we bring back to Earth, and that is the entire point. We have both lunar geology science, and we have human research on this mission. Human research is that we're participating in, everything from how we can top perform, behavioral health, immune response in space, which is a fascinating physiological response that humans have to microgravity. And there's a really neat new type of technology we're flying, an experiment called Avatar, where we're actually using chip, organ on a chip technology, cell on a chip technology to mimic how our cells, our bone marrow cells, will respond to microgravity in the radiation environment, to bring that science back to Earth, to understand how we can more efficiently send humans deeper into space and how we respond. So it's really exciting. We're happy to be a part of all that science. And talking about the lunar geology aspects a little bit, the moon is like a witness plate for everything that's actually happened to Earth, but has since been erased by our weathering processes and our tectonic processes and our other geologic processes. We can actually learn more about solar system formation, more about how planets form maybe around other stars, more about the likelihood of life out there, starting with studying the moon. And I think that's something, that question is, in my opinion, one of the biggest philosophical questions of our time. And I think some of the first steps to answering it start with this mission.
With that, we'll take the next question.
Good morning, Jeff Faust of Space News. Question for the administrator. As we're preparing to go around the moon with Artemis 2, I wonder if you can give us some thoughts on your plans for ensuring Artemis 3 can land humans on the moon by 2028. I know you've met recently with SpaceX and Blue Origin about speeding up the lunar lander development, but what should we be looking for in the months to come in terms of getting Artemis 3, keeping it on schedule, or at least ensuring a landing by 2028?
Yeah, it's a really good question. So one, we will just continue to be, as transparent as we can as we make progress towards the Artemis 3 mission. The way the public can best follow on and probably measure progress is just observing launch rate. I mean, that is absolutely the key to, unlocking the capability that'll be necessary to bring our lander to the lunar environment and bring astronauts down to the surface. So. I will say I did meet with both Blue Origin and SpaceX on their acceleration plans. These are both very good plans. I would say they both reduce technical risk from where we were before, so that's good. But in the end, it's going to come down to launching vehicles very frequently to learn. Learn about prop transfer for sure, but you're going to need reusability in order to do that. So I'd say we're all, if we're on track, we should be watching an awful lot of New Glenns and Starships launch in the years ahead.
We'll take the next question.
Good morning, Irene Klotz with Aviation Week in Space Technology. Sorry for the sun. For Jared, you've ridden a couple of rockets, you've seen launches, and you've seen Starship up close and roll out. Could you tell us what you think is special about this rocket, and if your opinion has deepened or enriched in the month that you've been administrator?
Well, I appreciate the question. We need more questions for the crew over here, because they're the ones about to embark on a pretty extraordinary journey on that vehicle. I would say I mean not a whole lot has changed from my perspective, other than getting I guess a lot of firsthand account of the people that and the effort that goes into building a vehicle such as this. And even more of the history that led up to this. Even just walking inside the VAB, which I've seen it I don't know how many times from the exterior, and then you go inside, you couldn't even find the SLS in there if you wanted to. I mean, and then that just brings back, what it must have been like during the 1960s when you had multiple Apollo vehicles in there, or at a time when or multiple Saturn vehicles in there, at a time when you had multiple shuttles in there. So. I'm halfway through a roadshow around the country to every one of our centers, meeting the workforce, trying to hear from those that are actually doing the hard work that it takes to pull off a mission such as this. So nothing changed in my mind about the importance of the mission that is NASA, our path to achieving it, but I've definitely had an opportunity to meet a lot of the folks that are helping enable it, and it's just extraordinary. So thank you.
We'll take the next question now.
Hi, Elizabeth Howell from SpaceQ in Canada, and this question is for Jeremy. You've often talked about how Canada has been taking all of these steps in space for decades alongside our international partners, clearly including NASA here, and you've also said, let's imagine what's next for Canada. And so in your mind, what's next for Canada in space once we finish this step? Thank you.
Thanks, Elizabeth. Yeah, I would just like to re-echo some of those previous comments, because against the backdrop of that rocket rolling, it represents an extraordinary American workforce right there, watching that thing roll out. And like Reid was talking about, we've been around and we've met them and we appreciate them. And no matter what their future is, that's a workforce that is trained to do extraordinary things. And they'll be redirected as we adapt and continue to do extraordinary things. And that is the same story in Canada. I've really applauded the American space leadership, because they carved out space for Canada to hone some of our skills, to develop workforce in specific areas and to bring that knowledge. And the future for Canada kind of looks like where the international collaboration wants to go. We aren't leading that collaboration. NASA's leading that collaboration, inviting our participation. We have skill sets, and I know Canada will rise to the challenge just like they did in the Artemis. When we were asked to join Artemis, we started to lean into developing new robotic systems for deep space. Even we're working on lunar surface stuff now. So we'll just bring that workforce to bear to meet joint collective objectives. And maybe I'll just end with, I'm actually pretty pumped to see that, because in just a few weeks you're going to see 4 humans fly around the moon, and if we're doing that now, imagine what we can do next. I'm pretty pumped to see that come to fruition.
We'll take the next question.
Hi, thanks for taking questions. Richard Tribou, Orlando Sentinel. This is for the astronauts, sorry, Administrator. Tuesday is the 96th birthday of Buzz Aldrin, and there's very few all men, who've flown around or to the moon. I think we are down to 5, and they're all over 90. So, one, I know many of you have found inspiration talking with them. I know General Stafford was hand in hand during Artemis 1. So can you each tell me what the Apollo crew have been able to teach you about what you're going to face? And also, if you want to wish happy birthday to Buzz, feel free. Thanks.
Happy birthday, Buzz. I'll just share my General Stafford story, which was the day we all got assigned to this mission publicly. My phone rang that afternoon. I didn't have the number saved. It was a Florida number, and I was thinking it was a telemarketer. I was on my couch. I was getting ready to take a nap. It had been a long day with the media, and I almost hit the red hang-up button, but I just figured I would answer it. I answer it, and it was General Stafford. Reid, congratulations. We are so excited for you. And I think that's the way the Apollo crew has always been. They are so fired up that we are headed back to the moon. They are so fired up that we're going on to Mars. They just want to see humans as far away from Earth as possible, discovering the unknown, the near impossible, as the administrator keeps saying for NASA as our charter. So we really love that. I also want to say, we grew up in the shuttle era, and we grew up in the International Space Station era. And 3 of us have been up there, and Jared's been in low Earth orbit. He knows what that feels like. So we do feel like this is an Apollo legacy, but for the 4 of us here, we are standing on the shoulders of the International Space Station and the science, the research, the long duration exposure they have had, and what we have learned up there.
I mentioned how I'm reading these journal articles from the 60s about Gemini and Apollo and some of the engineering lessons and piloting lessons that they fed into the system. But something that's also very interesting that you just kind of get between the technical data is the people that they were. And I do find a lot of inspiration in that, just understanding some of what their families were going through, what they were learning, or what they didn't know they were learning. As we look back, we have the benefit of hindsight. And so I've actually been very fortunate to become friends with Rusty Schweikert, and Rusty gave me a bag of wisdom, quotes from different cultures all over the world that I took to the space station. And I'm going to take that little bag of wisdom, but also in my heart and mind, the wisdom that we've learned from Charlie Duke and General Stafford and Dr. Schmidt on what it meant to them, and some of the story that hasn't even come out yet. We're still learning things from the Apollo era, and so it'll be nice to take the baton, run our best race, and then hopefully pass that baton on to the Artemis 100 crew.
I think what they've taught me goes beyond the technical tidbits and things of that nature. And the biggest thing I can talk about is camaraderie. They taught me camaraderie because I've had the privilege of interacting with them for actually over 25 years now through a scholarship foundation that they give back to or gave back to. And then more recently at NASA Remembrance events, which are kind of little reunions in a lot of ways for the Apollo astronauts. And seeing the way they interact with each other, seeing the way they tell stories and the way they still love each other and being around each other and what they went through together and how that bonded them has been really instrumental for me in appreciating every single day with my crew and with the larger teams. And I will never forget seeing Fred Hayes at one of these remembrance events, shaking his hand, and before I even said, "Hello, sir, great to see you," he goes, "I heard you're gonna break our record." And at that moment, he brought me into that camaraderie. And I made a promise that I will carry that forward and keep everyone in that spirit of camaraderie and carry it through our mission as well.
Apollo, just inspirational. I was inspired by Apollo as a kid. I think that's how I ended up here. I saw a picture when I was a kid of a human standing on the moon. It was either Buzz or Neil. But it just changed my perspective on things. I turned my Trios into a spaceship. I started exploring space in my imagination, and here I am all those years later. But for our crew, one of the required readings for this mission was Carrying the Fire by Michael Collins. And he does a great job of putting the human perspective in what was accomplished during Apollo. And it was pretty extraordinary. You were talking about it, Administrator, earlier, about like what they accomplished during that time frame. And I think it's a good reminder for us. I mean, we're doing extraordinary things now, but we can create even greater things in the future. We should not accept this as status quo. We should always be striving for more. And something else you wrote recently, Administrator, that I think touched all of us was just the appreciation for, we want to fly safely in space, but we also have to be willing to take appropriate risk. That's what this is about. And when we were reading Carrying the Fire, this is the part that really got my attention. Michael Collins jumped on a spacewalk from one Gemini spacecraft to the Agena. That's extraordinary. That is truly extraordinary. And so that was a courageous example, but they also weren't cavalier. They were taking calculated risks. And I think it's a great example for us to remind ourselves, hey, we're going to go out there, we're going to take some appropriate risk, and we're going to accomplish some extraordinary things. We're going to have some failures, some setbacks along the way, and then we're going to pick ourselves back up and keep going.
We'll move to the next question.
Hi, Kristen Fisher with The Endless Void. It's so great to see all of you on such an exciting day. You four are about to fly farther into space than any humans have ever flown, and with that comes some inherent risk, like you were just talking about, Jeremy. And so my question is, we've heard a lot about your training, but how are you training your loved ones? How are you preparing your families in these final weeks as you get ready to leave them behind on Earth?
Trying to train them honestly and openly is the best thing you can do. We just had all of our families together about a week and a half ago at the astronaut quarantine facility at the Johnson Space Center. That was one of the cooler moments in all of our training, just sitting around with our families around a conference table, and NASA was briefing them on the mission. Fellow astronaut Randy Bresnick, who was our technical lead, came in and gave them an amazing overview of the mission profile and the Orion spacecraft. And then there are the more personal touch points. I went on a walk with my kids. I told them, here's where the will is, here's where the trust documents are, and if anything happens to me, here's what's going to happen to you. And that is a part of this life. I actually wish more people in everyday life talk to their families in that way, because you never know what the next day is going to bring. So it's just important to be as open and honest as you possibly can. And then the other neat thing that has happened amongst all of us is our kids know each other, spouses know each other, we all text each other. It has developed this foundation that I know, even though it's a 10-day mission, I just know who everyone is going to lean on to get through this together while we're up there. On launch day, we've got the easiest job. We really have the easiest job. We've trained for this, we know exactly what to do, and it will be good. It's our families that we think about the most on launch day.
It is an interesting part of this journey. We have the entire resources of our agencies helping to get us ready, but we have to take the initiative to get our families ready. And we have a fantastic family support team, but we do have to take some initiative and lean in on that. And so those are tough talks, but you have to have those talks, or they can be tough. And you know, having the experience of doing this to get ready for the space station gives some neat experience, but also just something to compare and contrast with as well. And so we were having one of those tough conversations, and I mentioned to my family that, hey, you know, if I forgot to close the garage and we're all in Florida, I'll close it when I get back. You know, not 168 days later, but 10 or 11 days later. And so we you know, that is an important part, and thank you for bringing that up, because it is something that I think about a lot. And I am also really grateful that we have, I was actually just talking to Jared's family about when we were here to watch the Polaris launch. I was here to support a colleague and their family while they watched their loved one launch. That's my favorite role in this office. That is my most cherished, honored experience that we get to do with and for each other. And we have some folks that are going to be supporting us. 2 of them are here, our backups, Jenny and Andre. And we have escorts that are assigned to each of our families. And I just wanted to give them a shout out. We've all got someone, an astronaut, that is going to be with our family members when they're watching launch, which can be this terrific and terrifying moment all at the same time. And so I'm just really grateful to that team that helps us to get ready.
I think for us, in addition to all that, it's 2 things. First of all, I love talking to my husband. He's been very inquisitive about the actual technical aspects of the mission. These guys know my husband. So, you know, we're talking about what are the big milestones, what are the risky parts, when can he sigh a sigh of relief, when does he need to be glued to the TV, and talking about some of those technical things. Every once in a while we just get a question that comes out about the vehicle or how the mission's going to go. And then the second one is just a little more practical. I really have to make sure he knows that it's not like the International Space Station where we can just make a phone call. So he's not going to be able to call me and ask where something is in the house. He's going to have to find it. That's been a big one for us.
Pretty similar for my family. Over the holidays, though, we did watch some Artemis 1 launch video and entry video just to kind of point out a few things that can catch you off guard, like when the main engine's light. It does look like for a few seconds the rocket is blowing up, and then it launches. So letting them know about that. Also, the re-entry, what they can expect to see and maybe not see and not hear from us, and that's normal, and there's just a lot of different stuff there. And so during those times, to just be calm and patient and not make any assumptions. And then the other thing I told them, maybe this is good for all of you, is during the mission, you know, it's the first time we put humans on this rocket. And so we've done a lot of testing of these systems, but when we get to space, we will probably see signatures that look a little bit different from testing. Maybe not a lot different, but a little different. And then the team is going to do what the team does, and they are going to worst case scenario everything. And so if you hear any of it, it might sound really bad. It's probably not that bad. We're just going through what's the worst case scenario, what's the next worst failure, and that's probably going to be par for the course on a mission for the first time with humans on it.
Can I take a little license here and I want to just say something to you all. Thank you for being here and helping us share, you know, all of this perspective and time with and gratitude with the world. But you all have a really unique role. And what Jeremy said just reminded me of this, you know, how we talk about this is going to be based on how we think about this, what you believe. And this is a test mission. This is the first time. If we aren't pointing the thing right exactly at the spacecraft, we're not going to get that high definition downlink. And we could go, oh, darn. Or you could say, this is hard. And they're safe. And they're going to be back here in a few days. And so how we talk about those challenges, how you all talk about those challenges is going to affect how the world sees this. And what we're doing is you know, we're swinging for the fence, trying to make the impossible possible. And so I would just encourage you to think about that as we all go on this journey together in a few weeks.
And with that, we'll take one last question.
Will Robinson Smith with Spaceflight Now. Thank you for the opportunity. You all had the chance to go down to the pad when the ML was there. You've had the chance to get up into the rocket when it was inside the VAB, but pretty soon you'll have the chance to go back to the pad with your rocket and spacecraft there. I know you are liking to stay, you know, focused on the mission and preparation, but can you imagine for the rest of us that don't have that experience of what that day will be like, the first day you get to go out to the pad when your ticket to ride is there? Thank you.
I'm going to start with the simplest human element, which of course it's going to be amazing and all that, but I want to reflect back a month ago for our countdown demonstration test. We were in the vehicle assembly building. We were in Orion. Everything was fully powered. I was the first one to get in the seat. Ike gets into seat 2 next to me, and I was like, Ike, look, the dim button works on the display. And he's like, no way, because in our sims, that button doesn't work, and we can't dim the display at all. And I just want you all to remember, we are 4 human beings getting in this magnificent spacecraft, and sometimes the simplest things put a huge smile on our face.
That human piece, I actually try to keep a lot of that to myself. I think there's a time and a place for it, you know, and so excitement, for example, is something I get asked about a lot, and I don't let that out often. I think it can become a distraction, or it's a long story. I won't share it with you now, but I can tell you this, having walked out to 39A and saw a Falcon with a Dragon sitting on top of it, there was I'd say 300 milliseconds where I thought, I'd just be embarrassed if I walked out of this and said, I'm not doing this, that's crazy. But then I stood there in awe that, wow, we're actually about to go fly that thing. And then when they got to 10, 9, it was like, oh no, we're gonna fly it now. And so I actually look forward to that, even though I am focused. I'm glad you started with that. I am focused. I'm not excited. I'm focused, but I look forward to a moment like that with that beast.
As astronauts, one of the qualities that we talk about a lot is adaptability. This idea that, yes, you train and prepare for everything, but the most important thing is that you're ready to take on what you haven't prepared for. And so one of the things that these 12 years I've had in the astronaut corps has trained me to do is to not have expectations. So today is a day I trained myself not to expect. But looking over there, that's an amazing feeling. I think that on the day when we climb in, I always have heard this adage, and it turns out it's true. Astronauts are the calmest people on launch day. And I think we do that. It feels that way because we're just so ready to fulfill the mission that we came here to do, that we've trained to do. We are so ready to just give back that it gives us this intense feeling of calm and readiness. And I hope and try not to expect that I will feel that way.
Last time we walked across that pad for the countdown test that Reid was talking about, and you go up the first elevator and you're on the bottom of the launch pad and you walk by the bottom of the solids and the 4 RS-25s, and even in that moment, it wasn't fueled and it wasn't creaking and moaning and it didn't look super scary, but in that moment, one of the things that I felt was gratitude. And just like, I just see people when I look at that rocket. And people have poured their heart and soul into this vehicle, and it's truly extraordinary. And they're 24/7 here across the country, around the world. People are just pouring their hearts and soul into doing this because they're fired up and inspired by what we can accomplish. And so I know I feel a lot of things on that day, but there will be a fleeting moment at least of gratitude.
And we are actually going to take just one last question, and then we will wrap this up.
Yes, thank you. Oh, there we go. Thanks. Sorry, a little short. Sawyer Rosenstein with NASASpaceflight.com. I know one of the key things about this mission is the human factor of things, and I know you each get just a little personal kit that you can bring with you. Is there something special or sentimental that each of you is bringing with you that you're kind of proud to say, I brought this to the moon and bring it back to Earth?
I have a blank piece of paper and a pencil, and I can't wait to write some thoughts on that. I don't know what to expect, and I don't want to go in with any preconceived notions, so I know exactly where that note card is, and I can't wait to jot some notes on it.
My Bible, if that didn't go on the microphone, and an heirloom for each of my daughters and my wife.
For me, it's handwritten notes from people that I love. The idea that I can hold in my hands way out there, or in my case in the past on the International Space Station, I can hold in my hands something that they held in their hands and drew on or wrote on. That is really special to me. So I hope to find some in my care package when I get there.
Some things that definitely represent the people that put me in this position, but one of the most meaningful things is the 4 moon pendants that I gifted my wife and 3 children, I guess 2 years ago now. And they wore them for a while. I collected them back this summer, and they're on that vehicle right now, rolling to the pad.
And with that, We will conclude today. Thank you so much for coming out and for your interest in NASA. And thank you to the administrator and the crew for taking the time to answer these questions. Just a reminder that we will have a follow-on press conference and media availability with the acting deputy director or deputy associate administrator of ESDMD at 10 a.m. at the KSC press site. Thank you.
time now, just about 10 minutes to the top of the hour, 9:51 here on the East Coast. As you can see, the Space Launch System rocket continuing to make progress, slowly crawling on the Crawler Transporter 2 out to the pad at Launch Complex 39B. Just wrapped up, of course, the briefing with the administrator, Reid Wiseman, as well as the 4 crew members who are going to be flying around the moon on the Orion spacecraft they named Integrity. Reid Wiseman, Victor Glover, Jeremy Hansen, and Christina Koch with some good words about their feelings of the mission, the training so far, and as they emphasized a number of times, the people who have brought this hardware together and who are busily preparing to allow them a safe passage from the pad to the moon and back again. Certainly appreciate all of you who are watching along with us live here on the YouTube stream. As you're watching Spaceflight Now's live coverage of the SLS rocket and Orion spacecraft rollout from the vehicle assembly building. So we've got about 1.6 thousand of you watching along with us live. If you haven't already, you could do us a big favor just by clicking that like button and sharing the stream, allowing some more folks to find their way into this live launch coverage. As you're seeing the vehicle slowly back away from our camera's perspective, this is a really nice shot of the Orion spacecraft and the vehicle in total. This is a really nice vantage point of the Orion spacecraft with the European service module beneath it. All of it together makes up Orion. The crew module, of course, is the more domed part of Orion up top, currently underneath the fairings, beneath the launch abort system, or the LAS. You can see the 3 out of the 4 motors that in a worst case scenario would be able to very quickly get the crew away from the rocket. Back in September, when we had the opportunity to talk with a number of folks involved in the Artemis II mission, we spoke with the gentleman who you're about to see on your screen. This is the flight director in charge of Ascent, Judd Freeling. And we'll have more of his interview to share as we get closer to the mission, but I wanted to bring up this bit as we were talking about the LAS. In wrapping up our conversation, I asked him about some of the ascent and abort scenarios that really he doesn't get asked very often. And so want to go now to that part of our conversation. Again, this is Judd Freeling, the flight director over the ascent portion of Artemis II.
Everybody usually asks the right questions, like, do you have continuous abort capability, things like that. Those are all the right questions. Nobody really asks how dangerous it is to do an abort in the first place, right? I would say 9 times out of 10, if the vehicle systems are still healthy, you want to keep pressing on to your next abort capability boundary, right? Because the earlier you are in the mission, the more risky an abort is, right? And so I would say that's the question that nobody really gets out. You know, they kind of would treat all aborts as equal, and I'd say they're not all equal.
What would be the hardest abort to do?
Oh, last abort right off the pad is by far the riskiest and the hardest. You know, the last is designed to get away with the solid rocket boosters, and so it has a pretty good instantaneous acceleration. And if you're at a low altitude, whenever you're getting away from that, I mean, you're direct to mains, and so that's a pretty risky thing. Obviously, we feel confident that it'll work, right? Because we've certified it. But I would say just the time frame that all of that has to go just right is what makes it more risky.
And again, that was Judd Freeling, the flight director in charge of the ascent portion of the mission. He'll hand things off to the next flight director after the point of stage separation and heading into what's known as the proximity demonstration, when astronauts Reid Wiseman and Victor Glover get a chance to take the sticks of Orion, if you will, and do some manual piloting, performing approach and back away and targeting of the interim cryogenic propulsion stage. These prox-op operations are important because this is a precursor to future, what will generally speaking be autonomous docking between, initially, as things are currently architected, the Orion spacecraft and Starship from SpaceX as the first contracted human landing system vehicle. In the future, Orion will dock to the Gateway station around the moon in a near rectilinear halo orbit. And future HLS landers, as again things are currently architected, are designed to meet up with Orion at the Gateway, and then the astronauts would cross over into whatever HLS vehicle is being used for that mission from the Gateway, and then descend down to the moon surface and back up again to the Gateway. So this is the first step in that path to getting to Orion docking with Gateway and the human landing system Starship from SpaceX. However, of course, there has been a number of discussions about how to accelerate the Artemis 3 mission and some of the long poles in that tent, and one of those was reopening the contract for HLS for Artemis 3. Both SpaceX and Blue Origin did submit plans to NASA for how they would be able to move up the timeline potentially for an Artemis 3 moon landing. Those plans haven't been made public and presumably are still being reviewed by the administrator, Jared Isaacman, now that he's just freshly been confirmed and is very quickly been hitting the ground in his new role as administrator. Mentioned the Starship version of the human landing system. Go to this shot here. You can see the Starship Tower over at Launch Complex 39A that has been worked on for the last few years now. Teams are still going through reviews on the environmental side according to the FAA and have not yet given the green light for SpaceX to go full tilt in all of the changes that they want to make to this launch complex and then step into the process of potentially launching their Starship rocket from Florida, but presumably plans are that that will happen at some point in 2026 as the version 3 iteration of Starship comes to bear down in Starbase, Texas.
Dre got stuck out of the countdown clock and he's surrounded by people. I'm gonna go grab him. You guys go ahead and go back. I have to do that.
We are currently just about T plus 3 hours and 12 minutes, right about, since first motion with the SLS rocket and Orion spacecraft still lumbering its way down the crawler way atop the mobile launcher, riding on the Crawler Transporter 2 at less than 1 mile per hour, making its way down a bed of Alabama river rocks on a 4-mile journey out to Launch Complex 39B. To those of you still with us, glad you're sticking around. If you're just joining us, you're watching Spaceflight Now's live coverage of the rollout of the SLS rocket and Orion spacecraft for the Artemis 2 mission. And as promised in the video description of this live stream and in a social media tweet, we are joined by our friend and colleague and former member of the Spaceflight Now family, now a stellar reporter over at Ars Technica, still covering the space beat, Mr. Stephen Clark. Stephen, always good to see you, buddy.
Hey, Will. Happy to be here. Always a pleasure.
And it's been a busy morning. I mean, for a rocket that moves at less than 1 mile per hour on the ground, this thing has been booking it. You know, we've had the chance to see the astronauts watch the rocket go by. You saw this for Artemis 1, but what's been your takeaway from this crewed iteration of rollout?
Well, first of all, Will, I will echo that. That's exactly what's going to be my intro, was for something that moves at 1 mile per hour, it sure seems like everything's been in a rush this morning. So, yeah, we saw the rocket emerge from the vehicle assembly building, pause just outside the door to retract the crew access arm, and then resume motion, and it's been in motion ever since. If it's stopped at all, it's been very brief on the way out to Pad 39B. And then, of course, the crew here at the Kennedy Space Center press site, always a treat to see them. And for us reporters and photographers trying to transport ourselves from the crawlerway back to the press site, back to the crawlerway, it's been quite a hectic morning. But I'm happy to be here, Will. And so far, I would say the environment here has been pretty similar to what I remember for Artemis. What I remember for Artemis 1 a few years ago. Of course, that rollout, the first rollout for Artemis 1 occurred in the evening hours. This was in the morning, so we should be able to see the vehicle rolling all the way to the pad, or at least close to the pad in daylight, whereas for Artemis 1, the first rollout and most of the rollouts were at night.
Yeah, it looks like in the wide shot that it's just about to round the corner. And as we continue our conversation, actually still has a little ways to go before it actually reaches the bend. The straight-on shot's a little deceptive, I'll admit. But before we continue our conversation, obviously, you know, rollout is just one piece of the pie. Once it gets to the pad, there's a whole lot of work that has to be done before they even get to the point where they can tank this rocket for the wet dress rehearsal. So want to wind the clock back about 24-ish hours to when we heard from Artemis launch director Charlie Blackwell Thompson, who talked about what the pad flow is going to be like once the rocket is down and they can get into the nitty-gritty.
One of the first things that happens after we get to the pad, we get connected, is we'll do some crew access arm swings. That is about a day or so after we get there. Of course, the first part after we get to the pad is just getting all the connections, all the validations, getting tied back to the firing room, getting ready to power up the individual elements. And so that is something that, you know, you never want to say that's something that is routine, because you can have hardware that fails at any time. But I would say that's something that we did a number of times through Artemis 1. There are not substantial changes to that. We will get into our crew module work. There is some unique work that we did not have to do during Artemis 1 because we didn't have all of the crew systems. We have late stow, we have other things that we have to do. We're going to power everything up, all the elements. We'll get into pad PSET, mostly RF testing there. We've tested all these systems in the vehicle assembly building, but it's not in the RF environment of the pad. And so we'll go through and we'll do all of that checkout. we load the boosters. Again, there's some weather dependencies there, so we'll certainly keep an eye on the weather. Luckily, we're not trying to do it in the summertime when you have lots of thunderstorms, so makes it a little bit easier this time of year. There's nothing in particular through the whole pad flow that I would look at and say, this is the thing that is the driver to wet dress, right? All of the work has to get done. We have incrementally tested all of this offline or in the integrated environment of the VAB. And now it's just getting out to the pad and testing those pad interfaces, that launch pad environment with the RF. Wet dress is the big test at the pad. That's the one to keep an eye on. I guess if you're watching one and you say which one is the driver, that's the driver to launch. So that's the one to watch until we get to launch day.
And of course, that all-important wet dress rehearsal tanking test is currently scheduled for February 2nd. That's just 4 days ahead of the opening of the launch window, Stephen. One of the questions that also came out in the briefing, won't go to that tape right now, but was, what are the constraints to getting out of wet dress into, the launch profile, and can it be done in that tight of a time frame where, if they're trying to launch in theory on the 6th at the earliest, can you do a fully successful or a successful enough wet dress to have the confidence then to step in to that 2-day countdown? From everything you heard yesterday and the reporting you've been doing over the past, year plus, what's kind of your sense of that?
I wouldn't bet on it, but clearly NASA doesn't want to rule anything out at this point. They want to launch as soon as everything is ready to go. So if everything goes perfectly, which is a big if during the wet dress rehearsal, this is obviously only the second Space Launch System rocket they've had, and they had to do multiple WDRs, wet dress rehearsals, for Artemis 1. So I think if you're thinking they're going to launch on February 6th or the next opportunity, those first few days in February that are available in the launch period, I think you're betting on a perfect WDR. And it could happen. NASA doesn't want to rule that out. The other X factor here is the Crew 12 mission to the International Space Station. That's supposed to launch from the adjacent pad 39A here at Kennedy Space Center, also in the first or second week of February. From an operational perspective, that may receive priority from NASA leadership because the ISS now is on a scaled down crew of 3, just one U.S. astronaut on board, which really severely curtails the amount of science they can do, and also limits any repairs they might need to do in the event of a failure for a spacewalk or anything like that. So there's an impetus to get this next Crew 12, to the International Space Station as soon as safely possible. So if there is a conflict between them, I would bet on NASA going with the ISS crew as the operational priority. But the pads are next to each other here at Kennedy Space Center, but they're independent teams, obviously, from SpaceX and NASA. NASA's contractors working on Artemis 2. And then there's the factor also of Johnson Space Center, mission control, flight control teams working in adjacent rooms. Actually, there would be multiple teams running for Artemis 2 and the ISS and Crew 12, supporting all those operations at JSC. And then the TDRS, Tracking Data Relay Satellite System network, used for data relay and communications with the crew for Crew 12 while they're in transit, for the International Space Station during regular operations, and also Artemis 2 during the initial phase of the flight. Artemis 2 will be using the TDRS system as well.
Yeah, I mean, if you want to, game it out, say, Artemis 2 is able to launch, let's say wet dress goes perfectly. They're like, okay, we can posture to a February 6th launch date. If they're able to move Crew 12 up from February 15th to, say, maybe the 10th or a couple of days before, then you're talking about communicating with these two very crucial spacecraft as Artemis 2 is approaching the lunar flyby at that point in time. It would be pretty darn close to Orion going around the far side of the moon, and obviously they want to maintain communications with the astronauts. And, as we learned at the Johnson Space Center about some of the snap judgments that need to be made on scientific observations and adjustments based off lighting, they want to be able to relay that as expeditiously to the Artemis 2 crew as possible. And as you mentioned, that all goes through the teeter satellites, which are A, aging, and B, would, have a lot of splitting to do if you had a Dragon spacecraft also in transit up to the ISS. So it seems like a lot of traffic that they would want to potentially avoid, and that if Artemis 2 launches, it would create a 10-day buffer around it just to simplify things, if anything else. I mean, the administrator, Jeremy Hansen, said that it's important that NASA have the capability and should, progress into both at the speed at which both makes sense. But at some point, you got to get to the point where the two roads diverge, and, the one that leads to the ISS not having just one crew member on the USO side is probably arguably more important as far as an immediacy time factor.
I certainly agree with that. That the urgency to get new crew to the ISS for the safekeeping of the space station, because in the event of a hardware failure outside the ISS, the astronauts could need to go out and on a spacewalk, and right now there's only one American crew member certified for that at the ISS, and they obviously want to go out in pairs. So that would not be feasible with just Chris Williams on the space station as the only U.S. crew member right now. Theoretically, I agree with Jeremy Hansen's assessment that in 2025, NASA should be able to launch 2 missions in close proximity, support, at things as at the urgency, at the speed of required, or speed of readiness, I should say. And, if Artemis 2 and Crew 12 happen to be ready to launch on the same day or consecutive days, I think a 21st century space agency should be able to support that. But there are limitations, like you said, that are real practical logistical limitations to that in this day and age.
As we continue this conversation, I don't want to fully neglect our live chat here. So if channel members have a question for Stephen or myself while we're chatting here, please drop them in the chat and we'll address them as best we can. We got to hear from the crew in the couple weeks before they'll come back to Florida for the pad walk down, the first time that they're going to be able to go to 39B and actually see their rocket there at the pad with their Orion spacecraft, as opposed to the last time they were there, which I think was back in late 2023, early 24, when it was just the mobile launcher. They did address, I think, more in the realm of how they will feel about that moment on launch day. But that or that aside, Stephen, what were your main takeaways from hearing from the crew just now about less than an hour ago?
Well, I unfortunately missed the first half of the event because I was over at the crawlerway taking photos, so I'll have to catch the replay of the first half of the event. But they certainly seemed to be in good spirits. I was able to hear the answers to the last few questions and their excitement level to go out to the launch pad and do the walk down and do the final training that they'll do with the emergency egress system at the pad in the coming days or weeks ahead of the launch. And, of course, after the media event was over, we saw them pose for photos for media and then go over to some VIPs and some children, inspiring the next generation of potential future astronauts. So it was a really neat thing to see. So they seem to be very happy to be here and eager to go out and see the rocket when it gets to the launch pad.
Yeah, I think to that point of inspiration, I mean, one of the questions that was asked later, so you might have caught the answer, was about how the Apollo astronauts that are still with us, the conversations that they've had with them, what they carry from those. And, Christina Koch mentioned, a level of camaraderie, and, Victor gave a similar answer, just that it like a baton passing moment, essentially, of them being excited for the Artemis 2 crew. And, with events like this where you've got a crowd of both VIPs and kids, whether they're NASA employees or employees of dignitaries that are out here. I think it's important, and it clearly is to them, to carve out the time to be that Apollo era astronaut for these kids of, as Bill Nelson would say, of the Artemis generation.
Yeah, it's as I get older, it's really cool to see that interaction between the next generation and the current generation. And I had the opportunity to interview Charlie Duke a couple of years ago, soon after the Artemis 2 crew was announced, and he had a meeting with them right as they began their training with Reid, Victor, Christina, and Jeremy, and he shared with me his thoughts, that they were very capable astronauts, that, if he was applying for the astronaut corps today, he didn't think he would get in because they're so qualified, that he didn't really feel like he had much to add other than to wish them luck and still provide some inspiration to them, even though they're the current generation of astronauts. And he said he was honored to still serve as an inspirational voice for them as they prepare for their training for Artemis 2. So that was really neat to see that intergenerational dialogue between the Apollo astronauts, Artemis astronauts, and then today the future astronauts of whatever comes next.
Yeah, and it's not just the Artemis 2 astronauts that obviously the folks like Charlie Duke, the remaining Apollo astronauts, have been able to interact with, but also, extended out a little bit further, the companies that are jockeying for the Lunar Terrain Vehicle contract, and they're obviously taking inspiration and getting sage advice from the people who've, had the chance to ride on the lunar rovers of yesteryear, and, ask questions like, well, if you were in a more modern vehicle, where would you want this, stick shift? Would you want a barrier here so you don't accidentally flip a switch? How far is too far to ask an astronaut to reach over and lean over when you're in a pressurized EVA suit? Things that only a select group of people can say firsthand that they've got experience with, that, they're trying to pass down before, their knowledge and legacy, goes away with them. I think is, something interesting to see in all these various pieces of the Artemis architecture that go beyond just sort of the marquee missions, like with what we're about to see here later in the spring.
Yeah, and I agree. I think there's something to be said for continuity as well. I've had thoughts, in the past, would NASA ever go back to the moon before all the Apollo astronauts are gone? And to see this, mission, they're obviously not going to be landing and walking on the moon, but, with this crew, for the foreseeable future, we can say, well, there are people alive who have been in the vicinity of the moon, have seen the moon up close, and I think that continuity is really important. We hear a lot from NASA about 25 years of continuous human presence on the space station. There are people alive, many people, billions of people today, probably around the world, under 25 years old, who have never been on Earth when astronauts haven't been in space. So I think having just fellow members of the human race who have traveled afar and seen Earth from deep space walking among us, I think is really a really cool thing that we're privileged to have here in 2025. And with this crew and future Artemis crews, we're going to have it for a while longer.
And obviously, all the attention until Artemis 2 is back on the ground, from the Moon to Mars perspective, will largely be focused on these four individuals and all the support teams behind them. But I have to imagine, in the not too distant future, when this mission wraps up, that there's going to be a lot of interest and fervor of, so who's flying Artemis 3? Because if you're going to be, meeting the president's deadline of, getting back to the moon before the end of 2028, if that is a reasonable expectation, presumably they are already training, because, there were previous dates that have shuffled to the right considerably. And, you've got to familiarize yourself with not only the Orion systems, but also Starship systems, and also the Axiom spacesuits. Like there's a lot that go into the Artemis 3 mission, that just doesn't exist with this, lunar flyby, new orbits, new trajectories. Astronauts like Raj Achari and I believe Randy Bresnik have been conducting some lunar landing training with helicopters here in the States. And so, you see little breadcrumbs of like, we're seeing a lot of this astronaut doing that activity. So maybe they're lining up to do that. I would hate to speculate on who actually will be flying, but your thoughts on how soon potentially we might reasonably get an answer to that question. Do you think in 2026, or would this be a 27 question?
I don't know, Will. I think within the next year or two will be my answer. Whether it's 2026 or 2027, I'm not sure. But you hit on a very salient point that the crew that NASA selects for Artemis 3 will have a lot more to do than Artemis 2 to prepare to fly. They need to train on the Space Launch System. They need to train on the Orion spacecraft. They need to retrain on the Human Landing System, likely Starship, but to be determined. They need to train on lunar geology. They need to train a lot more on science than this crew has had to do. And so there's to pack all that in, a couple or 3 years' time, I think is is a reasonable expectation, to assign them to at least 2 or 3 years before they're going to fly.
And I'm really glad that you brought up the science portion of it, because, a lot of the sort of directly involved science that Artemis 2 is going to be doing, they've got the Avatar tissue chips that are flying with them. That's, fairly hands off. They've got the bands that are going to be monitoring their physiology during the flight, besides, wearing that the whole time. That's fairly hands off. A lot of it is the observations that they're going to be making of the lunar surface, of the fine details that the human eye can parse that cameras maybe aren't as keenly tuned to, or as adept at, really pulling out those particulars that NASA would want to understand for future exploration. But the fact that Artemis 3 and beyond are really going to have to dig, literally and figuratively, into the geology side of it, of, once we've got, potentially the Viper rover, if that arrives around or before the Artemis 3 astronauts land, do you have a water ice component of the mission? What does that look like? I mean, there's a whole suite of science that I'm sure NASA is very, deeply dissecting and parsing and making sure that they've got it pared down to optimize, the conditions of flying a new lander, whatever lander it ends up being, to the moon, around all the science that they're going to want whoever A flies and B lands to conduct. And so, like I said, it's a lot to expect in 2 years or 3 years, even if they have, been training for the past year or so.
Yeah, I think you're exactly right, and there's still so many unknowns, particularly with the suits and the Human Landing System, about will there be design changes when they start testing them, particularly the Human Landing System. When they SpaceX starts doing their refueling tests in low Earth orbit with Starship, and when they do the uncrewed landing, that's going to be ahead of the crewed landing for Artemis 3. So a lot of big milestones where lessons could be learned and changes could be made to the design of the vehicles or the suits before any crew gets in them and tries to land on the moon. So, and of course, Artemis 2 has to go well. I mean, this is a test flight. We've heard that often from NASA. This is why you test. So, Artemis 2, I'm betting something will be learned and something will have to be tweaked for Artemis 3, hopefully something minor. But any rework or any redesign or modifications that they have to do in Artemis 3, or reviews or analysis or testing based on what they learn out of Artemis 2 will be a driving factor into when Artemis 3 flies as well, and potentially, if you rewind the tape, when they announce the crew.
Yeah, I mean, even pieces that ostensibly went quite well with Artemis 1, they were still making tweaks to for Artemis 2. Like, for example, if you we'll go to the tighter shot here of the rocket in just a second, but if you look just to the left of the rightmost tip of the solid rocket booster, you can see one of 4 strakes that Boeing added just beneath the bottom of the launch vehicle stage adapter. You can see those actually on either side of that feed line there in the middle of the rocket. And so I say little, but things like that to pieces of the mission that were successful, but they're trying to get better performance out of, certainly given the fact that this is the first time that you're going to have humans give feedback on what it's like to live inside Orion, undoubtedly, Lockheed Martin and NASA and all of the subcontractors that work on Orion will have plenty of takeaways and little things to tweak and manage when they get Orion back down on the ground and they're able to look at its performance. And, while the heat shield of Artemis 3 is not the heat shield of Artemis 2 or Artemis 1, it'll also be the first time they're flying that trajectory with that heat shield. So there's definitely going to be learnings coming out of that element of the mission.
Yeah, absolutely. Well, I think the heat shield, the reentry profile, the aerodynamics of the strakes that we mentioned a moment ago. Also, this is the first time that Orion has flown with a full suite of life support systems, crew displays, the seats, crew comfort, the toilet, the galley, all those things on board Orion will be flying and will be tested for the first time on this mission. So lots of data and lots of information for NASA to consider coming out of Artemis 2 before going on to Artemis 3.
And I think, just speaking for myself, but one of the more admirable things about this crew is, when you talk to them about, some of the milestones of, potentially seeing a part of the moon that human eyes have never seen because of the lighting conditions during Apollo, and just, the going the furthest distance any humans ever have, and being the closest to the moon since the 50s or the 60s and 70s. They're very stoic and I think measured about, like, yes, that would be good, but we're also resolved if the decision is made that we go into low Earth orbit, something is wrong and we have to come back home, because this is just the second time this vehicle is being taken out of the garage and taken for a spin. The first time that it's been manually piloted, and as we heard in the September 25 briefing with the crew at the Johnson Space Center, if something like the toilet doesn't work, they're probably not going to spend 10 days in the Orion spacecraft and go to the moon. Like, there are definitely a number of human related showstoppers to this mission, and it's admirable that they seem to be at least outwardly facing at peace with that.
Yeah, certainly. I think it would be a big disappointment to them, no doubt, to NASA and to all of us watching it if they don't make the translunar injection and go to the moon. But that being said, just the fact that the crew's in the spacecraft, if they are able to complete some manual flying, check out the life support systems in low Earth or high Earth orbit, that's still quite a bit. And depending on what went wrong, what prevented them from going to the moon, that in and of itself may not be a showstopper for Artemis 3 going on to the moon and attempting a landing going forward. But we're in the realm of hypotheticals now, so we'll see.
You literally read my mind. That was where I was going to go with the conversation next, because that came up in the briefing yesterday of, how far is far enough in this mission that you can potentially not go to the moon, but still say we're good to continue on into a moon landing attempt with Artemis 3. And it sounds like obviously the most important thing is get Orion up, get the crew back safely. That's, paramount to NASA above all else, is to get the crew back safely, whether they reach the lunar flyby or not. But So unfortunately for those listening, we're going to have to let our friend Stephen Clark go here in just a minute. See, just a quick question. How long till the rollout's over? It's over when the rocket reaches the pad. Not being entirely glib, though, the whole rollout timeline was expected to be somewhere between 8 to 10, possibly as long as 12 hours. So we're cruising into hour 4, about 18 minutes outside of 4 hours plus the first motion. So still got a number of hours left to go. I mean, the rocket still hasn't reached the point where it's going to make the turn towards the pad. For those who watched the rollout for the Artemis 1 mission, you may recall that it was about at this point that NASA made the determination to pause in the rollout and correction, they were almost at the gate when NASA paused and swapped out crews to relieve the teams that were in the process of rolling out and bring in a fresh crew to bring it into the finish line. It's our understanding that the crew that is in motion right now is the crew that's going to bring it in to pad 39B, so there shouldn't be a point where you do a stop and swap, if you will. But before we let our friend Stephen go, just in wrapping up with you, we've got a couple weeks left before the planned wet dress rehearsal. Obviously, some checkouts will happen before then, testing the vehicle in the RF environment. We'll see the crew come back out here, do a walk down of the pre-fueling launch escape system parameters. What are you kind of watching for? What do you have your eye on in the run-up to NASA making a determination of launch date post-wet dress?
Well, other than the wet dress rehearsal itself, one of the big tasks that requires hands-on work at the launch pad will be the servicing of the booster hydraulic power units on each of the 2 solid rocket boosters. So they actually have to fill those hydraulic power units on each booster with hydrazine to power those units. Those are the units that drive the thrust vector controls on the booster for steering in the first 2 minutes of flight. And those have to be loaded when the weather conditions are favorable. It requires the technicians who fill the reservoir with hydrazine to wear protective, it's called scape suits, self-contained suits for their protection, because hydrazine is very toxic to humans. So all that has to happen with good weather. And we heard yesterday, obviously this is January, this is not in the summertime, so we're not having to worry about afternoon thunderstorms every day, so that will be in NASA's favor. Or hurricanes, exactly. Yes, or hurricanes, exactly. So the stay at the pad from a weather standpoint should be pretty uneventful, and all that leading into the wet dress rehearsal around February 2nd, no earlier than, well, I don't know if NASA used the term no earlier than, but around February 2nd, and then that will be the determining factor for the launch date. And the launch dates they have in February run through the 11th, is that, or is it the 12th?
I believe it's the 11th, but I don't have the calendar in front of me right this second. But I think you're correct.
And then the next batch of dates are in the first week of March.
Yeah.
So, and we also heard yesterday from, if my understanding was correct, or memory is correct, from Charlie Blackwell-Thompson, that they could stay at the pad throughout February. They don't have to roll back to do any servicing of the flight termination system. That was a big constraint for Artemis 1. They had a limitation. If they didn't launch in a certain launch period, they had to roll back and retest and then return to the pad. They currently have a means to do a limited retest of the flight termination system at the pad. They've introduced that since Artemis 1. And Charlie Blackwell-Thompson, the launch director, said yesterday they have the ability to go through the February window and the March window before they would have to come back to the VAB.
Yeah, I mean, that is certainly a big benefit to how they've changed things up between Artemis 1 and 2. And, as she detailed as well, the lessons learned coming out of, propellant flow with both the liquid oxygen and liquid hydrogen that caused a lot of issues during there were 3 wet dress rehearsals before they rolled back the first time for the non-weather rollback. And, of course, you had the red team that had to go to the pad on the day the rocket actually launched to make sure that last-minute issues were not a showstopper, and they were, kind of the last-minute heroes of that day. Thankfully, the launch was able to take flight, and it was a spectacular launch. But yeah, no, it's going to be important to get through those final tests. And no, you've got to run. Stephen Clark, for those who missed his introduction, is a space reporter over at Ars Technica alongside colleague Eric Berger, and you can find him on social media. His handle at X is Stephen Clark 1, if I'm not mistaken. Stephen, always a pleasure, my friend.
Yep, thanks, Will. Always a pleasure to join you, and be back here for the launch in a few weeks, hopefully.
Fingers crossed it's a good wet dress. See you later. just a little past the top of the hour here, 11:04 a.m. Eastern, 16:04 UTC for our friends joining around the world. If you're just checking in, you're watching live coverage from Spaceflight Now of the rollout of NASA's Space Launch System rocket and Orion spacecraft atop the 322-foot tall launch vehicle. The rocket has been slowly progressing from the vehicle assembly building where it had its first motion at 7:05 a.m. Eastern and is moving at a speed, it has been moving at a speed of about 1 mile per hour or less. So it's a slow crawl out to Launch Complex 39B. Mission managers estimated it could take between 8 to 10 or maybe more hours to reach the launch complex, where they will have a hard down once they have arrived safely and can start the work of integrating the mobile launcher and the rocket's various systems and link those up into the firing room 1 inside the Launch Control Center. Time now just about quarter past the hour here, 11:16 on the East Coast, 16:16 UTC for our friends around the world. Continuing to track the progress of the SLS rocket making its way out to Launch Complex 39B. Earlier in the broadcast, we had the opportunity to talk with Paul Benfield, the Orion Artemis II spacecraft manager at Lockheed Martin. And in part of the conversation, we, of course, discussed the heat shield and the analysis that was done after there was some additional char ablation that was seen on the heat shield as it was coming back in through the atmosphere that was not initially predicted by the modeling from NASA and its partners. Since then, there's been a lot of review and analysis and additional testing to better understand the dynamics of the heat shield in preparation for flying, either making the decision to fly the heat shield as it currently existed for Artemis II, or whether a whole change of heat shield was needed. As things turned out, they decided to fly the heat shield that they've got, but change the trajectory a little bit, so not going for the skip entry. Last year, when the Artemis II crew was here for some work and actually in the flow of another unrelated crew launch, we had the opportunity to hear directly from the crew members themselves on how they were feeling about the decision to fly the heat shield as it currently exists, but with the new trajectory. So here, in their own words, are the crew of Artemis 4 on why they felt comfortable moving forward with the hardware that they've got.
The concern was in-plane cracking that was discovered due to permeability on the previous heat shield. It's very well documented online. I recommend everybody go read the report. It's really fascinating. There's some great pictures and a lot of great technical background in there. We had what was called the char loss team at NASA, and it was headed in the Orion program, and they did a tremendous amount of research, a lot of kind of groundbreaking research in some facilities that we had not used before, and they discovered the root cause, which was the key to this whole team, was let's figure out the root cause, and then let's see where do we need to go. Artemis 3 will fly a different architecture. Artemis 2, they pulled the data, and they scrubbed, and they did wind tunnel testing, and laser testing, and hypervelocity testing, and they determined that if we come in with this lofted profile with a 1775 horizontal target line downrange, that this heat shield will be safe for us to go fly. We're actually even looking now at pulling that back even a little bit more to give us some flexibility on landing day. So they think there's a little more capability in this heat shield than at first they realized. So I think all that points in a direction of goodness. And I think if you as a human being that was about to board this rocket had sat in the meetings that we've sat in and listened to the experts and gone through the data with them, you would have the same comfort that we do.
Yeah, and I think it's important to, well said, and I won't readdress any of that, but you brought up, former astronauts and other space professionals, industry professionals who have had comments on this. A lot of those are outsiders that haven't been in these meetings from day one and met the team and looked them in the eye and shook their hands at the ends of these meetings. But the other thing is, I don't want to discount the things that they've said. Anytime you talk about fire, anytime you talk about entry and heat shields, you talk about parachutes, these are high risk things that are sometimes they don't have fault tolerance built in. They have to work. And so I appreciate all of that nudging and poking and prodding that they've caused. They have made us sharpen our pencils and put more due diligence, more vigilance into that process. And so, but I think we have done that. And so I think the crew is comfortable because of that team, and we know how many people were looking at this, but at the end of the day, they were thinking about us and our families when they were doing their jobs.
And I would say that that appropriate skepticism led us to a culture, which is actually ultimately why we are comfortable. That culture is not about litigating a case of why we can fly. It's about doing the science to understand the systems and then making a decision based on that. That could be either rationale to fly or to not fly. And that's ultimately what got us to this point of being comfortable.
Yeah, I just want to put a little bit more emphasis on the fact that I think it's really important that this story gets told, and it's great that you're asking about it, because this should be characterized as a true American success story. I mean, this country now knows things about heat shield technology it didn't know. And that's the art. That's when you know you're pushing the boundaries, is when you figure something out you didn't know.
And what they've done with all this learning is they put it in this category of us being able to understand the risk and make a risk trade. And now for us, when we look at the heat shield risk, there's always going to be a risk there, but it is in family with all the other risks we're going to take on a mission to leave Earth and fly around the moon.
Local time now 11:43 a.m. Eastern, 16:43 UTC. We're just about T+4 hours and 38 minutes after first motion of this rocket back at 7:05 a.m. Eastern time. Want to welcome in a couple new channel members here on the YouTube channel. Welcome aboard to Krob 20661, joining us with membership at the pad leader level. And a special welcome to one of my former colleagues up in the Huntsville area, Mr. Paul Lockhart. Good to have you with us as a channel member, also at the pad leader level. Hope you've been doing well. Also thanks to channel member Josh King, who's been with us now as a member at the pad leader level for 39 months. Really appreciate that, Josh. Thanks for your enduring support of what we do here at Spaceflight Now, and to all of our channel members that help support live launch coverage and, of course, big launch coverage or big special event coverage like Rollout today. Well, of course, after the rocket reaches Launch Complex 39B at the end of this 4-mile journey, teams will look at the rocket configured for checkouts in the radio frequency or RF environment, as well as preparing for the crew to come back out here and do one last walk down to get familiarized with the escape system at the pad that, should it be needed, would be available before they get strapped in and the launch abort system is activated on Orion. The big determining factor to liftoff or setting a launch date, though, is getting through the wet dress rehearsal tanking test, where more than 700,000 gallons of liquid oxygen and hydrogen will be flowing on board the rocket. So in taking forward some of the lessons learned from Artemis 1 and the trio of tanking tests needed before the rocket rolled back to the VAB and they had to bring it back out once again, we heard yesterday from Artemis launch director Charlie Blackwell Thompson about some of what was learned from that and how they're bringing that into the flow of things, pun intended, for Artemis 2.
You know, one of the things that we learned and we worked our way through was, first off, it was a brand new vehicle. And so, as you know, we had some challenges through the wet dress, first with the LOX loading and making sure that we had the loading CONOPS that we started with and the one that we ended up with were slightly different, right? And that had to do with the fact that we were using some amount of legacy hardware, and we found that as we regulated the LOX pump, as an example, in our first two wet dresses, that if you think about having a single stage and an upper stage, and you have that piping that goes up the tower, as you regulated that pump and it slowed down, you would get some warm LOX that would fall into that fill stream of the core stage, and so we had some trouble getting to the right inlet temperatures there. Took us a couple of tries to figure that out. Then during wet dress 3, we had some issues with some hydrogen leaks, right? Hydrogen leaks, so we worked our way through that. We made some modifications to our ground plates. We changed the way in which we loaded hydrogen, and we got through our wet dress campaign, and then we had a issue with the replenish valve on the launch attempt number 3. Where we finally launched, right? We sent a red crew out to the pad and we worked our way through that. So if I were to kind of step back from that and say, what's that biggest lesson that you learned? Well, the first one is on the LOX side of things, we learned how to load. We learned how to change our CONOPS for that. We're utilizing the same CONOPS. Once we made those changes and we worked our way through launch countdown attempt number 1 and number 3, we used that same philosophy and CONOPS for Artemis 1. It worked successfully, and that's what we plan to use again. So that was a big lesson learned. The other lesson learned on the hydrogen side of things, we made some changes to that interface between the flight plate and the ground plate. We made some changes during our Artemis 1 campaign to improve that so that we did not have leaks where you have the flex hoses and the connections on the back of the plate. We saw very good performance during the launch countdown number 3. for that. The interface between what we call the cavity, where those plates come together, we saw some hydrogen leaks there. We learned that the way in which we loaded and the flow rates, the temperatures, the pressures have a whole lot to do with the leakage that we saw within the cavity. And so we modified that, and we were able to manage that through launch countdown number 3. We had the issue with the replenish valve. We went and we made a modification post Artemis 1 to that valve, and we tested it with cryos for the replenish time frame with as many cycles as we would expect to have during Artemis 2. So, so why do we think that we'll be successful in Artemis 2? It's the lessons that we learned, right? Artemis 1 was a test flight, and we learned a lot during that campaign getting to launch. And the things that we learned relative to how to go load this vehicle, how to load LOX, how to load hydrogen, have all been rolled in to the way in which we intend to load the Artemis 2 vehicle. Now, what's new, right, for Artemis 2? Well, Orion's got some new systems on board. They've got a new ECLIS system. We've got the crew interface piece of this, and we have tested those things offline to ensure that, you know, they're not influenced by the cryogenic environment of tanking, but they are used in day of launch, and they have to be used in accordance with our launch countdown and that critical timing. And so we've gone through and we've done a countdown demonstration test. We did a suited crew test before we even got to the VAB. And so we've taken this incremental approach to the testing for the new systems. And so I believe that we'll be ready for wet dress. Again, we'll see. This is our second hardware build for the core stage, so we'll see how it performs. We don't have the benefit of a green run, but we believe all of the lessons that we've learned from Artemis 1, we have used that countdown and that philosophy as our building blocks for Artemis 2.
Local time now about 12:20 here on the East Coast, 17:20 UTC for our friends joining around the world. As we're taking a look back at the 322-foot tall rocket in the straight-on shot, you can see Artemis 2's moon rocket is finally making the bend towards Launch Complex 39B. We've been in motion here for now about 5.25 hours, as, of course, we learned yesterday that this process would take about 8 to 10 hours in total, maybe as many as 12 hours in duration. And of course, we don't want to leave you bereft of views of the rocket as it's making its way out to the pad and once it gets there. And so some of you may have gotten a notification, especially if you have your notifications turned on, but we have just flipped the switch on our 24/7 Artemis live stream. And that'll be the place to go for 24/7 views of the rocket as it continues to make its way out to the pad. And once it's there, you can go ahead and check on it day and night. And especially when we get into some big milestones in the run-up to wet dress, we'll have some partial coverage there. We'll have a dedicated wet dress stream, of course. But we'll be popping into Artemis Live periodically to give you updates on the progress of the mission, any updates to the timing or the flow of things, if there are any hiccups or things that need to be fixed. That'll be your place to go from a visual standpoint, and we'll usually post a tweet or something to let you know if there's a time when you should listen for additional audio and commentary, specifically on the Artemis Live YouTube stream. So as we get down to potentially the final 2 weeks for this Artemis 2 launch campaign, we look forward to bringing you additional robust views, interviews, audio, visuals of all the things around the mission, from the astronauts themselves, the training they received, the mission timeline itself, and of course, the run-up to launch. Want to thank our moderators who've been helping us out in this dedicated rollout stream. Big thanks to all of you who've been here throughout the course of this early morning to mid-afternoon broadcast. Thanks to one of our channel members, Cumulus Granatus, who was able to help answer some folks' questions in the chat. Thanks to our guests from Lockheed Martin, as well as our friends in the media, to Stephen Clark and Richard Trabue from the Orlando Sentinel. Big thanks, though, to our photographers who literally, if you check their Apple Watches right now, probably shows that they've clocked at least 2 miles walking and jogging today. So big thanks and well done to Adam Bernstein, Michael Caine, and John Pisani. You can find their work at their handles on X, ABurnNYC for Adam, MD Caine Jr. for Michael, and John Pisani Photo for John. Thanks as well to our Spaceflight Now editor, Stephen Young, who's been running the technical operations of the broadcast. And as you've been watching the tracking camera pivot throughout the course of the broadcast, Stephen was also making sure that that remained in frame, and we certainly appreciate that. Most importantly, though, thanks to you for wherever you've been watching from. We certainly appreciate your time and attention. And again, head on over to Artemis Live whenever you'd like to get your daily dose of the Space Launch System rocket and Orion spacecraft integrity. For all of us here at Spaceflight Now, I'm Will Robinson Smith. Remember, be good to yourselves, be good to others, and we will see you next time, folks. Until then, enjoy your weekend, and bye-bye.